In this course, we're going to cover Playwright automation using TypeScript, and we're going to talk about different tools within the Playwright that you can use to make your automation easier. All right, without further ado, let's get into how TypeScript is different from JavaScript. So TypeScript is a superset of JavaScript that extends JavaScript with static types, helping developers catch errors during development before they turn into bigger problems in production. While you might not notice much difference between JavaScript and TypeScript in small Playwright tests, TypeScript can be highly beneficial for larger automation projects by improving maintainability and reducing runtime errors. Additionally, starting with TypeScript version 7, support for the Go compiler will improve performance for larger projects, potentially making TypeScript the new standard for Playwright automation. JavaScript is dynamic, loosely typed. Types are determined at runtime. The TypeScript static, strongly typed with optional annotation. Types are checked at compiler time. Compilation. Interpreted directly by browsers, no compilation step required for JavaScript. TypeScript compiled to JavaScript before execution. It requires a build step. Error checking. Errors appear at runtime, potentially leading to unexpected behavior with JavaScript, but for TypeScript, errors detected at compile time, reducing runtime errors and enhancing code reliability. Object-oriented features. With JavaScript, it supports object-oriented programming but lacks certain features like interfaces and generics. TypeScript offers robust OOP support, including classes, interfaces, and generics. Learning curve. Generally, JavaScript is easier for beginners due to its simplicity and flexibility. TypeScript might be a little bit steeper learning curve due to static typing and compilation concepts. Okay, so let's compare JavaScript code with TypeScript code. Now, one important notice with TypeScript: if you're creating TypeScript code for an app, this TypeScript code will have to be compiled into JavaScript code. With Playwright, though, you have actually a built-in TypeScript support, so no manual compilation is needed. If you create code in TypeScript in Playwright, it will automatically transpile during test execution. Okay, so we're going to take a look at some of the common problems that JavaScript has and then how TypeScript can help solve this. Here is example number 1. There is a missing parameter, and the function greet.js accepts a name and the age, and then it will print out hello name, you are age years old. So whatever you pass through will be printed out. Now, if I call this function, it will be printed out as undefined, and this will just go through during the runtime with an error showing. In the TypeScript, though, you can have the type defined assigned to the variable, so we accept name as a string, and we have age now as an optional value, and it will be a number. And then there we can have some logic. So, for example, if age is not equal to null, then we have a whole string printing out. But if age is not provided, then we're going to just return hello name. So if I just call greet user TypeScript and provide only the first name, it will run this line and no problem during execution. Here's a second problem. Missing required argument causes runtime error. JavaScript allows calling functions with missing arguments. This will crash with a message cannot read property to uppercase of undefined. So the same case where a function accepts 2 parameters and then returns the first name and then the last name with to uppercase. Now, if I only pass through one variable, then it will try to run to uppercase on undefined parameter, and it will crash the program during the runtime. So it's not just going to be undefined display, you will get an actual crash. The solution with TypeScript, you will have to enforce that both parameters are provided. So first name as a string type, last name as a string type, and then return first name, last name to uppercase. Now, if you try to compile it with only one variable back to the JavaScript, compilation will fail and it will say that argument is missing. So you're not going to even get into runtime errors. You'll be forced to fix the problem before it occurs. Problem number 3 is inconsistent return types in JavaScript. So without full knowledge of application working, you might have something like this in place, where you try to check if a person is adult, and if age is higher than 18, then return yes, else return no. But what we're actually expecting either a true or false value coming back. So in TypeScript, you can have explicit return type annotation. Here, check is adult will accept type number passed in, but it will return a Boolean. So it will return either true or false, depending on what number is being provided. So if you say 20, it will return true. In case of JavaScript, if you say 20 and there's no type check, you might by accident return a string, which is something that we don't want. Problem number 4, wrong argument types accepted. So JavaScript performs type coercion 5 plus 5 equals 55. So it does string concatenation and then expected mathematical addition, but got string concatenation. For example, we have a calculator function that accepts a and b and then returns a plus b. So we want to know how much we're going to get back. But if you try to pass in JavaScript one value as a number and the other one as a string, instead of getting 10, you will actually get type coercion, and as a result, you will have 55 string instead of 10 number returned. In TypeScript, type parameters prevent wrong argument types. TypeScript ensures both parameters are numbers. It prevents string concatenation bugs and forces mathematical addition. So we can specifically define that A should be a number, B should be a number, and it should return a number. So if you'll try to pass along a string here, it will not allow you to compile, and instead of a string, you need to use a number parameter here. Problem number 5, accessing non-existent properties. Runtime error cannot read property lengths of undefined. No way to know if property exists until runtime. For example, we have username Alex inside the users, but we don't have email property. And then we try to actually access this property. We say users.email.length, and this will crash at runtime because there was no value to access and JavaScript never checked for it. So when the application is running, there is no value, it's undefined, it will actually crash. With TypeScript, interfaces with optional properties and safe property access, TypeScript define object structure and checks property existence. So you have interface user, and it has a username as a string, an optional email value as a string, and you create a variable users ts, and it's type of a user, and it has username Alex, and email is optional, so it can be omitted. So TypeScript enforces checking if optional property exists before using it. So that means if users has an email, it will print out the length of an email. If user doesn't have an email, then it will print out email is missing instead if someone's trying to actually get the length of the email here. And then problem number 6, mixed types in array. Array contains both numbers and strings, and that breaks type assumption. Any logic that assumes all items are numbers will fail or behave unexpectedly. So in TypeScript, you will enforce that all array elements are the same type. It prevents mixed type arrays that breaks type assumption. So we have arrays stored in numbers ts, and we make sure that all values within that array are numbers. So if you try to put not a number here, again, when the compilation happens from TypeScript to JavaScript, you'll get an actual error pointing to the problem instead of allowing this application to run and figure out that there's something actually wrong when you already have your code in production. So that would be the main benefit of the TypeScript, and the main difference. It has a lot of checks in place. The code still compiles into JavaScript, and then that JavaScript runs in the app. But if something is wrong during the compilation, you don't have a type, or the wrong type is passed along, all of that will show up. So effectively, none of the broken code gonna get into production, and everything have to be fixed because it will fail during the compilation process with meaningful errors showing what is wrong. Right? So this is the core difference between JavaScript and TypeScript. And the TypeScript is a subset of JavaScript, just has the types enforced in it. Hopefully this explains the difference, and let's move along to actually using TypeScript in Playwright.
We're continuing Playwright automation with TypeScript. So today we are in module 2, and it is Playwright introduction module. Now in this module, I would like to do a couple of things. I would like to install Playwright with TypeScript. I would like to explore Playwright config file that gets created and see some of the options that we can set there. I would like to look at the package JSON that is created for the Playwright. I would like to run some example tests and explore different ways to run those tests, and also review Playwright test report. Now, if you would like more details on getting started with Playwright in official documentation, you can use this link. I will also have it as part of the video additional material. All right, let's get started. All right, so to get started with the Playwright, I need to have Node, or you have to have Node on your machine. Now, I know my Node version is a little bit outdated, so I'm just going to download the latest one. You go to nodejs.org, hit download, and let's get it going. All right, so once download is complete, go ahead and launch the file. So it will have the node welcome message. Let's hit next, accept, default folder, just next. Install the necessary tools, sure, next, installed, and Node.js is being installed on the machine. Okay, so Node installation is completed successfully. It also pops up a window asking for some other additional tools to be installed and asks to press any key. Let's do that. All right, so all the installations are done for Node.js. Now, next thing is go and install Visual Studio Code. I have one already installed, so I don't need to do that. And after that, we just go into the Playwright official documentation and look at the installation. So there's an npm command, npm init playwright at latest. So just copy that. Open your Visual Studio Code and navigate to a folder where you want your Playwright tests to be. So I created Playwright TS. I am in that folder right now. And I'm just gonna right click and paste the command from documentation. So npm init playwright at latest. Hit enter. Okay, so it's asking if I want to use TypeScript or JavaScript. We're selecting TypeScript. Asking where I want to have my tests. Inside the tests folder, that is okay. GitHub Actions, false. Install Playwright browsers. Yes, let's install them. Okay, it is initializing the project, installing everything. So let's give it a minute. Okay, so looks like everything is installed. And if I'll also do node -- version, you can see it's 22.14. You might have a different version. If you install the latest one, your version might be newer, so that is okay. And now if I'll expand this folder on the left, I can see I have Playwright files here. There is an example test, some other files that were created by the Playwright. So let's start looking through them. The first thing we're going to look at is Playwright config file. And inside this config file, you have the configuration for your test to be running. One of the things that we can add is some default values for like timeouts, how long the test is gonna run. So if I'll type here timeout, and let's say we're gonna do 60. So 60 multiplied by 1,000, this will give us 1 minute for each test. So there's a time frame, and you can change that. So 60 multiplied by 1,000, so 60,000 milliseconds, which is 60 seconds per test. If you want a different value at some point, you can go ahead and change that. I'm going to move this comment, have it over here, over timeout. So each test run should be maximum 60 seconds. If you need a different parameter, you can just update this value. All right, next thing, let's do global timeout. So how long is going to take to complete all of the tests, the maximum time? So for that, I'm going to say, so I want 10 minutes, right? So I'll put 10, then multiply by 60, so 60 seconds in a minute, and then multiplied by milliseconds. So we get 10 minutes as maximum time. We want all tests to be completed within 10 minutes for the whole test suite. Yep, that looks good. What else in this config? We have here a test directory, testdir.test. So right here, we can see it in the left. That's where our test is going to be located. And that is where Playwright gonna look for the tests when to run, execute them. Parallel is fine. Retries. So retries will happen only in CI. Let's give one retry on the local environment when we run on our machine as well. Workers, unlimited amount of workers on local machine. This is fine. So if it can handle reporter, we're going to have HTML reporter. This is okay. Trace on first retry. So if something gets retried, we'll get a trace. And let's also add headless true. We can change this parameter, but if we want our test to run in headless mode, we will have headless true. If we want to actually see browser opening up and see how tests are getting executed, we'll just update it to false. Now, right now we have the project to run in 3 different browsers, so Chromium, Firefox, and WebKit. I'm gonna highlight from the Firefox to the WebKit to the end of it, press Control// to comment at all. So I don't want them. For now, I just want the test only to run on Chromium or Chrome, right? Desktop Chrome. Okay, that's it. We don't have a base URL yet. We will configure that later. Okay, so I think everything here in the config looks good for the starters to get us started. All right, now let's take a look at package JSON. So this is the file that gets created when you to install the packages, and you can see dev dependencies. And here you see Playwright tests and types node. So all of the packages here, whatever you keep on installing through npm, will go into the node modules right here. And we can see we have a Playwright here, add Playwright, Playwright core. So different packages got installed was the initial command. Now within package JSON, there is a thing called scripts when you can specify scripts that you want to run. So right now, if I want to run the tests that I have that are located inside the tests folder right here, the example tests. So it will check if Playwright dev has a title, and the title should contain word Playwright. It will check that the get started is there. So it will go through those 2 tests. And in order to start executing, I need to say npx playwright test in the console. So this will trigger the two tests that I have right now. And you can see they're both running in Chromium. They're running in headless mode, so we don't even see how the execution is happening. And both of them passed. All right, perfect. Now, if I'll go back to package.json, I can actually have customized scripts, and it's a common practice because you can have multiple different scripts you need to run. Sometimes you need to combine them. So I can say test. So this is going to be my first like alias. And for the test, I will have npx playwright test, right? So just like that, within the scripts, now I have alias test, and when I say test, it will execute this command. So let's do npm now, run test. And it's doing exactly the same thing as we were doing before. But instead of typing the whole command, I can just say npm run test, and it will run this, right? Okay. There are some other ways we can start testing. We can say that we maybe want to test in the UI, and this is like one of the good ways to start if you're just getting started with the Playwright to kind of see how everything is happening. So npx playwright test -- UI, hit enter, and it's going to bring the user interface. Here it is. Within the user interface, you can see project selected. So there's just Chromium selected. And then I have the tests here. So one of the tests within the example spec file, this file, it shows me there are two tests, has title and get started link. So let's run has title. So hit the run button, and we can see that in the UI, there's the whole flow. We can kind of click and run through the timeline here and see what is going on from the start to beginning in each step. So we can see it navigates to playwright.dev. And then it does an assertion that it looks that in fact there is a title, and it passes the test, right? So you have all your actions here. If you click off, you have all your actions. So starts with some before hooks that do configuration for you. Then it goes to the page. Then it does the assertion, and then some after hooks that doing like after test configuration for you. So I can see every step in the UI. I can see the action when I go before and after the action. So there's an action to navigate the state of the page before the action. So it was just a blank page, and after the action where it completed and actually on the page. I can see network calls, what is actually was happening in the network. I can see console or any errors or anything. I can even pick up locators, like I can interact if I want to. So if I click pick locator, I can also grab a locator for a different element on the page if I want to add something later to the test. So within the UI, you can kind of see the whole flow of a test from the beginning to the end and get a lot of information for the test. You can run the specific test, you can run multiple tests, you can run the whole collection. So both of the tests, you can filter by passed and failed. So this is very useful when you're getting started to have all the information in front of you. Okay, so that is running the UI. And also I would like to pack this up and make this command shorter and put it in the package JSON, so as another script. So I want to separate this script with the new one. Let's do test UI and just paste the command that we used in the console. Right. right here. So now we can also execute the test using npm run test : UI, and it will run this command. All right, good. Now, also, if you notice, there is a Playwright report. So in order to open a report, you need to issue the show report command, npx playwright show report. And if I run it, the report will be generated, and the tests that are run will be shown here. So there are two tests. They ran on the Chromium, how long it took, the test file, and the tests inside the file, and both are passing. So you can see pass. You can also filter by failed or flaky, something that is took multiple attempts to pass and skipped. All right, so we have a reporter. So let's say I want to run a test and open a reporter when the test execution is completed. So we can also do that. So let's clear out the console, and in the package JSON, we're going to add another script. We will say test, and let's do :report, right? So we have both. Two commands will be running here. So first we will do npx playwright test, and then right after that we will execute. So putting shift7, so end, and again another command, npx playwright show report. Okay, and I can test this out. So I'm gonna run my test and then generate reports. So let's do npm run test report. Two tests are running. They're finished executing, and immediately it runs the command to show the report. Okay, perfect. All right, so now let's see how we can have, let's clear this out, how we can have just a regular run, but in a headed mode, not in the UI, not in the headless. So in the config, we said headless true. We can say now headless is false. And if I'll run my test now, and I'll say npm run test, you will actually see a browser opening up. And they open up in a different window. So to prevent it from the execution, I'm going to insert a pause here. I will do await page dot pause, just to kind of give you a preview of actually browser being open. So let's run it again. Okay. So here, when I run and I have a pause, you can see the execution is paused when the command is inserted right here on the very first action when the browser is open. And now I have a Playwright inspector where I can see the script that is running, and I can click through steps. So I can say step over, and it's gonna go and navigate to the page. Again, step over, and it will do the assertion and complete the test, right? Okay, so now you've seen the actual difference between headless and headed mode. So let's go headless back and put it to true in the Playwright config. Okay, one more thing. When we run tests, sometimes we want to tag the tests. So some tests can be specific, like for regression testing. So we want to add a tag. So let's do that. And to add a tag to the test, we need to put it here next to the title. So for the second test, I will add a tag. So after comma, in parentheses, we say tag, colon, and in quotes, I'll say at regression. So let's assume this is our regression test. And now we need to put another comma here. Okay, so I have a tag for this test. Now I can run a particular test with a tag. So I can say npx playwright test, and I can run it with a tag using the grep command --grep at regression. Okay, and also let me change this back to headless false, so I can see a browser popping up, and let me add a pause here so you can see when the page is opened. Page.pause. Okay. Let's run it. So we're running this command npx playwright test --grep regression. Argument is missing. Let me add this to quotations like this. All right, here we go. So it's a little bit different on Mac and on Windows. So you need to have your tag in quotations on Windows machine. All right, so we're running just the regression, and you can see the inspector opened and only on that particular test. So let's do next step. Now it's going to navigate to the playwright.dev. Here it is. Now it's going to find the get started link. It found it. Okay, clicked on it. Now it found the installation, and it should have heading. So it's going to assert that heading is there, and there's has name, installation, and it is visible, so users can see it. Next step, and the test is complete. All right, so let's also add this script to run only regression tests. So test regression. And you can see, like, you can add options, and I have Copilot doing suggestions here. So it says, okay, you want to actually run it headed because this is how you ran it, or headless. This is a CLI command and a runner. So we want to remember that whatever is in your CLI, in your command line when you do an execution, will overwrite what it's in your config. If you don't provide any options in the CLI, it will run what's in config. But if you have something different in CLI, it will overrun the config. So for example, in the config, I can say headless equals true, right? But the pause is still in the test. So if I just run regression with headless being true, it's just going to execute it without opening a browser. It's going to ignore the pause. It's just going to immediately go through it, right? And it passes. Now I'm going to grab this command, and I'm going to update what we have in the package JSON for the command itself. The argument, if you want to run tests and see them, is headed. So headed. So npx playwright tests are headed, and we're going to grab regression, even though in the config it says headless true. Okay, let's see. So what should happen now? We will run this command from the package JSON, and we will see the browser opening up because we have headed here. Even though the config said headless is true, but the CLI specifies we actually do want to see the browser popping up. And we're doing it only for the regression test. So let's go ahead and run it. So npm test, npm run test regression. Okay, here's our command. it is running. You can see the browser popped up, and it is stopped because we have a pause. In the headless mode, we didn't see the browser pop up, and it would ignore the pause argument, right? Because you don't really need a pause if you're in headless. There's nothing to debug and go through step by step. But here, because it is headed, it is showing the browser, it is pausing. And I'm just going to resume execution by clicking this resume button. Okay, and the test is completed. Some other things that when you run the test that you can do, you can specify a project. So right now, I have Chromium and I have a Firefox commented out, right? So I can, let's uncomment it. So highlight this Firefox, uncomment it. And now I can say npx playwright test, and then -- project equals Firefox. Run it. And it's going to ignore the Chromium in the config, and it's going to run only the Firefox. And you can see the browser right here. Firefox has been executed. If I'll open the report, so npx playwright show report, for the last run, you will see the execution happened in the Firefox right here, right? The browser is Firefox. With both of the projects uncommented, if I'll run it again and remove it, project Firefox from the CLI command, run it one more time. Now it will actually execute both in Chromium, Chrome, and Firefox browsers. And you can see now there are 4 tests running. Why there are 4 tests running? Well, because 2 tests are, there are 2 tests and they're running one time they're running in Chromium and the other time they're running in Firefox. And now if I'll open my report, and now I can see that, tests in Chromium and tests in Firefox. There are tags added next to the tests. If you want, you can also specify a specific file that you want to run. There are a couple ways you can do it. If you want, you can do test.only. And if you have test.only, and I will do npx playwright test, it will grab only this test and it will run only one test. You can see it's executing has title, and it executed it once with Firefox and once with Chromium. Let's remove Firefox. So I commented out, I run it one more time. Only has title will be executed. Yeah, one test. Let's clear it out. If I want a specific one without using .only tag, I can actually provide the folder. So tests, that's where the tests are located. And I can say the file that I'm going to run. So example.spec.ts, so the whole file. It will only grab .only tag now, but I can also be very specific and I can say I want to execute only line 10. So down to the code line. So I want to execute line 10 and run it. No tests found. Okay, let me remove .only tag and do it one more time. And this is because, all right, hold on. Tests example spec.ts. Here we go. Okay, so there is a difference, like it's auto-completed with a backslash, a forward slash, or backslash. So there's a different way how different operating system structures the path to the file. So if you're in Windows, so test /, I think if you were like on Mac, the backslash would work. So it didn't find it because it was a weird way how it auto-completed it was dot and backslash, but in Windows actually you do npx playwright tests, and then tests is the folder, goes in the tests, and then you need to have slash or forward slash, and then examples.spec.ts colon and the line, so 10. Okay, now let's see if it's gonna ignore dot only. So it should ignore the dot only and then go and run only test 10, because this is that we provided it specifically in here in the CLI. Let's run it. Okay, and let's open the report. And then in the report, we can see that only get started link was executed. So this particular test that we provide here after the colon. Now, I prefer to do that only when I'm debugging something, and maybe pause the test when I'm doing execution and still run the default command, and it will pick that only, and it will open it up if it's in a headless false mode, so in headed mode. That is the typical way how I go and look into the test. Okay, so we looked at a bunch of different ways of running tests, both through scripts and package JSON and the CLI. Now, we looked at running tests using the test-UI. One more thing that you can do to run tests is to use the extension. So if you go here in extensions in Visual Studio Code and type Playwright test for VS Code and install it. Once you install it, and after install and refresh, you will see this little testing thing popping up. In the testing thing, like on the side here, you can expand it and you will see your tests. Now, if you don't see the test here in the testing, when you have the testing tab open, make sure that the projects are selected, and you see it's picking up projects from the config. So if I want more to show, I need to uncomment the other one. So I'm going to uncomment Firefox and WebKit. Let's go back to the testing tab for the tool. Now I can see a bunch of different projects. So Chromium, Firefox, and WebKit. So as soon as I select projects, I have tests appearing. And let's say I want to run them only in Chromium. Okay. Tests, example. You can see it's disabled in Firefox, disabled in WebKit, so enabled in Chromium. And I want to run only get started link, so I can do that. Okay, I click run test, and it will pop up and run the test. Okay, and it passed. It looks good, completed. The difference, the window stays open, it's not closing here. You can also debug test and run in a debug mode. And when you run in a debug mode, so if you put a breaker somewhere, like a dot here, so I added a breakpoint by clicking to the next to the code line, the red dot, and gonna run it in the debug mode again. So this is only the get started link, run it in debug mode. Okay, and you can see that the test execution is actually paused right here on the breakpoint when I'm doing a debug. And here is the browser. So I can do the same thing. as I'm doing when I pause, but this is from the debug console. Now I can do step over into the next step. I can step into this step and see what it will do. Okay. And now it's in the page, gets into the role. I can go into the next step and it will verify. Now it's in the installation verification. Step into this. Okay, it's actually confirmed. And another last step to finish up and close it. Okay, and test is completed. And it's passing. Here's the report. So this is if you want to use the debug mode. There is also a continuous run. So if you have a continuous run on, so as soon as you update something here, so I'm going to say get started exclamation mark, it will rerun the test. And because I put in an exclamation mark and stopped it, you can see it's responding by saying it couldn't find the get started exclamation mark, because on the page, remember, this is get started button, it doesn't have the exclamation mark. So wasn't able to find the text, wasn't able to click it, and the test essentially failed. Even though I interrupted the test, I stopped it, but it just reports that couldn't find it. Okay, all right, so in this video, we installed Playwright with TypeScript, installed Node. We explored the Playwright config file right here. We explored and looked at the package JSON, not the log JSON, just the package JSON, and different scripts, how to run different types of tests, configuration for the tests. We looked at the example spec file and updated how to run each test through like that only tag, through the .only, or through the tag regression. And we looked at the Playwright report. So I think that should be it. Like, this is your starting point and introduction to the Playwright with the TypeScript. And yeah, I'll see you in the next video. Bye. So today in this module, we're going to talk about Codegen Playwright tests. It's module 3, and we're going to get like a brief introduction on how to generate tests, even if you've never written any tests, but using the tools that Playwright has. So we will generate tests using Codegen. We'll understand and clean up the generated test code. We will explore the Playwright assertions created by the Codegen, and we add both positive and negative login scenarios. And we will organize tests using test describe blocks. The command to start Codegen is npx playwright Codegen and the name of the web page. And you can see more details on Codegen in Playwright official documentation. All right, so let's get hands-on. Okay, so here we are in our project, and we have some example tasks that we walked through during the Playwright introduction. So there are a couple ways how you can start recording your tests. So one of them would be actually go into the Playwright documentation, and you can look up Codegen in the documentation, and there's a command there. So if you go to Playwright dev /docs/Codegen, there's introduction, and let's just do Codegen. Okay, running Codegen, right? So here we are. Codegen intro, running Codegen. So you can do the npx playwright Codegen and the web page that you're trying to do the Codegen. So this is what we're going to do, but there's also another way, because during introduction we installed the module for Playwright, right? So if you go to extension, we installed extension. So if you go into the extensions and you type in Playwright, so we have the Playwright test for VS Code installed. Now, this extension has some tools, so you should see this test or testing flask. and you can record new or you can record at cursor. So if you're at the web page, you can start recording at the cursor and kind of grab from where you at and continue. If you want to try with the new page, you can just hit record new. So you can see it created test-1 spec.ts, and this file is right here. And now it's recording, so I can go on the new line. There is Playwright Codegen recording is going on, and there is a blank page open. So here I still have to navigate, so I can paste the link and press enter, and you can see how it started recording. And as I go through this and type things out, it will do the recording for me. Tom Smith, right? And then super secret password, exclamation mark, and then log in. And then here I have the message, and I can say insert text and hit it, right? So it pretty much followed along what I was doing and recorded it, and then I can just hit cancel and the recording will stop. And looks like a bunch of things got outside of the test block, so I need to just cut it out and put it inside, and let's format document. Okay, so now we have the test block, and this was generated using record new using the Playwright extension, right? So, but that's not what we're going to do. What we will do, we will just use the command that they have in their documentation on the web page. So we're going to use npx playwright codegen, and then we need to type in the name of the page here. And we will be going to the Internet Heroku app. So https the Internet Heroku app .com/login, and I'm going to just delete this file and let's run it. So pretty much the same thing is going to happen now. However, we see, so it navigates right away. It navigates right away to the page, but now instead of recording it directly into a file like it was before, it's going to record everything here in the inspector. All right, so the Codegen is going to record everything here. So you see, I clicked it and it recorded the click. Then I'm going to type Tom Smith, and it typed Tom Smith. Then I'm going to go into the password and type super secret password, exclamation mark. And you can see, okay, typed incorrectly. And I'm going to hit login button. And I can see there are a couple things that are visible now. I can do some assertion. So let's click assert text. I'm going to assert you logged into the secure area. And let's also assert visibility of a logout button. All right. So now I can just grab all this, highlight it, and copy it. So copy. Let's create a new test file. So a new file would be code, let's name it codegen.spec.ts. So you have to have .spec for the Playwright test, and then just paste the whole thing in here. In the console, I'm just going to stop. So in the terminal, I'm just going to press Control-C to cancel it out. That's it. So the page stays open, but the inspector is gone, right? Okay, I can close this for now. Perfect. So the test was generated. So let's see what it actually did. So test, we started the test with the test function, right? And then inside of it, something actually got out of the block. So this, I'm going to delete this. Okay. So inside of this test block, we have the name of the test. So this is the name of your test, right? So this will be in the quotes. After that, you say async, because async is the keyword that will allow us waiting for everything executing line by line, waiting for the response. So you have an asynchronicity. Not all of the responses coming in the same time, so you want to wait for each step to continue. You need the asynchronous. Then we have a page here. So the page is a built-in fixture in Playwright. So instead of setting up the browser, setting up the context, like configuring everything, everything is done with this page fixture. So before each test, you will have a new page running for each test separately in the browser that you put in the config, and all of this done with the help of this page in parentheses here, right? Inside the round brackets and parentheses. Then we open up the function itself. And here inside the function, we'll have all the steps. So first we say start with await, because again, you have to wait for each step to complete. And the first step that we're doing is going to the website. Then the second step, as you saw, we clicked, we got the text box by the role, and inside that text box, there is a username. So we clicked into it. And again, this whole thing, the locator and everything was generated by the Codegen. Then we typed in, so fill Tom Smith into the username. Then we clicked on the text box with the name password inside. And then we filled the password value. And then we clicked on the login button. And then we come to our assertions. So 2 assertions, we generated one. There should be a text. There's a flash locator, ID flash, and it contains the text you log into secure area. And then another one that we now see once we log in, there is a logout button that should be visible. So all of this was generated. Let's run it. We can run it. I'm gonna delete the example. I don't think we need it anymore. And then in the config, let's see, it's going to be headless. So that is fine, but it has a bunch of browsers. So let's limit just to one browser. We only want Chromium, so I'm going to comment out the rest. So Control / it's going to comment out. Control S to save. Let's clear the console. So I'm going to run it in one browser. It's going to be Desktop Chrome. And it's going to go to the tests folder right here, and this run all the files there, and there's only one file, Codegen spec.txt. So we can do npx playwright test. All right, and it's going to execute, and you can see this is the name of your test. So that is the value, the name of the test that we had. And looks like, all right, it passed, and we can click or type in npx playwright show report. So let's do that. And port is already in use. I think show report 0 space 0. Like that, maybe. Okay, so port is in use. Let's see how to check the Playwright report. Actually, we have a Copilot here, so I'm going to check with the Copilot. Report how to select a random port. There's a command to select random port if your port is already busy. Port and set. Okay, so port 0. So you want to do flag -- port equals 0. So if you're having trouble viewing your report because the port is already occupied, you can do it like this. Okay, so here's our test, Codegen spec TS, ran in Chromium. the before and after hooks, like you don't see them in the code. They're built into this page, right? Inside this fixture, the page. Okay. And here it is passing. Everything looks good. All right. I think we're doing pretty great. All right, let's clear out the console. Okay, so what is next? So now let's generate a test that will actually gonna fail. So we have both a positive and negative snare. So I'm just gonna press arrow up to go back and to the command that opens up the page. And let's run it. Okay, so here's the page open again. And now I'm gonna just type in fail user, and let's type fail password. Doesn't matter. It's something that is just invalid, and I have a typo here. I can see the typo. There's fail password. That is fine. And now we click login. So this will not work, right? The username and the password are wrong. Click login, and then it says username invalid. So we want to assert that this message actually came up. So assert text right here, and then click on the text. Confirm this is the text you want to assert. I'm going to remove the X there and additional space. Confirm it. And that's it. So we have the code. I can just grab the test code and put it here. Okay. So now let's stop the Codegen. So Control C, it is closed. Clear out the console. And let's run a specific test. So let's name this negative login test. So because it fails to log in, and let's name this one as a positive login test. Okay. And now I'm going to do npx again, playwright test, and it's going to run both of them and report. 2 passed. We can see a report. Or if you want to do npx playwright test --UI, this is going to open up a UI runner, and we will see both of the tests available here. So there's a positive and negative. Let's run them both using run all. And kind of spread this window a little bit. So they both passed, and I can navigate through the timeline here and see what happened, right? So it logged in, went to the page, typed in username, password, hit login, and got inside. And then the negative test. So again, got to the page, typed in fail user, typed in wrong password, attempted login. Then the fail message came up on the screen and asserted it, right? Okay, that is pretty good. So we have 2 tests now. Now, the only thing that you want to do probably when you have multiple tests that run in one module, like they try to test one functionality, and in our case, this is the login functionality, right? You want to put it in a describe block. So this way, you can have more context what's going on, right? What kind of section. So let's ask again. I have a copilot, so let's talk with the copilot. Put both tests in the describe block. So describe block serves as a way where you can kind of group your tests together. And instead of ask, I'm going to do agent. Let's run it. Here we go. And it already recognized that both of the tests are login tests, so it create describe block, and there's a problem. Okay. This is like when everyone says the AI can replace us, the testers, developers, like small things like that are everywhere. So you want to say test dot describe, right? So describe is within the test, part of the test that we imported from the Playwright test. So test dot describe, and we can say login tests. Then there's nothing here. And then both inside the parentheses, we're going to have both. Nothing within the round brackets, but inside the parentheses, we have both of the tests. So here's one, and here's another. Do not add anything. What happened? What are you doing? All right, whatever you're trying to do, I don't like it. I'm not sure, something off. It tries to auto suggest changes that. Let me turn off the agent. I'm just going to put ask. So test dot describe, and here we have the block, right? So all we need to do is just put those two tests inside the block. So Codegen tests for login, positive, and negative. Okay, let's just grab those two and put them inside a test block. All right, click format document. All right, and now we can just go to our runner, npx playwright test, and run this. See, two tests are running using two workers at pass. Let's grab a report. Again, dash port equals 0. Port equals 0. Here we are. So now we have test 1, test 2. And you can see it says Codegen test for login, positive and negative, and then positive login, and then negative login. So they're now grouped within the describe block, two different tests. And then if you have some other functionalities or some other modules, you can group them in its own describe block. I think that's it. That gets us started with the Codegen and generating a couple scenarios here. Login that is passing and failing. And yeah, I'll see you in the next video. Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. And today we're in module 4, and we're going to talk about Playwright Locators. So Playwright Locators are a powerful and flexible way to find and interact with elements on a web page during automated testing. Playwright provides a high-level API called Locators that simplifies handling dynamic elements, weighting, and visibility. You can get elements by role, you can get them by text, you can get them by label, you can get them by placeholder, you can get them by alt text. Typically, this is used for images. You can get them by title, or you can get them by test ID, which is configurable in the Playwright config if you have a unique test IDs. We're going to take a look more in details at the documentation as we go through the video. Now, when learning about selectors locators, it's essential to understand the fundamental of HTML element structure. There's an opening tag. Now, within this tag, you will have attribute or many attributes or one attribute. And those attributes might have values assigned. Then we will have inner text, and then we will have a closing tag. Expand your HTML code, and you will see multiple HTML elements like this. They will be nested in one another, And there's a way how you can interact with them using CSS and XPath. And Playwright also supports CSS and XPath selectors, even though they do recommend using Playwright Locators first. Some examples of the CSS is grabbing by ID, where you would use a hashtag, grabbing by tag, by attribute and a value, or grabbing by class name by putting a dot before the class. There are also possibilities to grab the locators by XPath, and you can match XPath selectors, for example, by tag and by ID, where you would say page.locator, and then within the parentheses, you'll say XPath equals / the tag, then the attribute and the value. So input at ID equals username. And then the action you want to perform, for example, fill the text field with the username. Or you can even match by partial text match by using contains. So the typical locators that you use in, let's say, Selenium using CSS and XPath are also available in Playwright. Okay, so now let's get into it and try some of those hands-on. I'm gonna start with the Playwright documentations for the locators, and it's important to get into a habit of using Playwright doc when you're trying to figure something out and you're not sure how to do something. Going through the documentation and reading about a particular method you're looking into or something that you're trying to do is very important. Make it a good habit. Okay, so here we have all the Playwright built-in locators. And here are some examples. So we're looking here at the button that has a text sign in. And here we will be getting this button by role. So we know the role of this element is button. So we mention it right here after opening parentheses. And then in the additional options, we provide name sign in. So it grabs this text and uses as the name of the button. Here, we can locate by, this is by role, this is another example to get by role. So heading, H3 here, element sign up is a heading element and with the name sign up. And we are verifying that this element is visible. Then there's a checkbox. And again, we're grabbing it by role, checkbox, and by text subscribe. And the button that we already seen in the previous example. Then we can locate by label. So label is also a tag, and we can say get by label password. And then the advice when to use label locators, use this locator when locating form fields. Locate by placeholder. So placeholder is the text that you will see in the field as an example text before you start putting in your own text. So there's a particular attribute, it's called placeholder, and then you can grab the value by using get by placeholder. And when do we use it? We use this locator when locating form elements that do not have labels but do have placeholders text. So if there's no label you can grab it by, but there's a placeholder, you can use this placeholder. Locate by text. So if there's a visible text on the page, you can also grab by text, an element by text. And then alternative text would be text that typically assigned to images to describe what they are. So there's an alternative text Playwright logo, and you can use await page.get by alt text and grab this value. You can also use by title. So if there is a specific title, you can grab that. But all of those values that we're looking at, right, they are all different forms of attributes, right? There is just an attribute that is an ID. There is just an attribute that is a class name. There is just an attribute that is a title. You just have to understand they all still follow the same structure of a tag, attribute name, attribute value, inner text, and then a closing tag. Locate by test ID. So by default, Playwright uses data-test ID as an attribute, but if your team is using a different test attribute in the HTML, you can provide it in the Playwright config. So you can actually configure your own test attributes that Playwright will use. Okay, and then there's some examples of locating by CSS and by XPath. To have some examples written down, let's use the Internet Heroku app.com/login, the one that we used previously for Codegen, and in the test folder in our project, I'm just going to create a file that is called new file locators.spec.ts. So here we can type out the locators, and we're going to go through some of the examples that we talked about in the slides. So first, let's start the test file so it can run. So we're going to do import test and expect from Playwright test to get it started. And let's just define our first test. So I'm going to name it test examples of Playwright locators. I think this is good. Expand this a little bit. So examples of Playwright locators, async, we have a page. And first step, we're going to navigate, just to navigate to the page to get it started. So await page.goto. And this is where we're going. So the internetheroku.com login. Good. Let's first have some of the examples of built-in locators. I'm gonna say examples of built-in locators. All right, so first one we will do get by role. So let's take a look at this login button. Inspect it, and we see that it is a button, right? And this button has some text. It has text login. So I can get this button by role. Let's create a variable. So const, we're going to store this element inside this variable so we can interact with it later. So login button, and it will be page.get by role. So the role is button. And then in additional options, we want to also provide that it has name, right? Login is the name for it, the text inside the button. So name, login. Okay, and let's add an assertion. So we will assert after the page loads. So we grabbed it by role, we stored it in the variable, then we will assert that this variable is actually visible. Okay, perfect. So let's close this out and just give it a quick run. And see how this goes. I have a typo in the test case name. So it's a spec.ts. Okay, let's give it a run. And it is passed, looking good. Finished, load the page, and asserted that the button is visible. Okay, let's see some other example. We can get by text. Get by text. And let's take a look at some of the text that we have on the page that we can assert on. So there's a login text at the very top right here. So you go click inspect, and it's header 2 text. And we can assert by that as well. We can grab it and assert it. So let's do the same thing. Let's create a variable login header text. And again, store this variable. So page get by text login page. That's the value that we're looking at, right? And we're gonna assert, so await expect login header text to be visible. I can also, let me open a UI actually for this. npx playwright test -- UI. So it's a little bit more visible when the execution happening. So we are again in the locator spec. So let's run it. Let's go into the page. Page is loaded and it highlights. So first it highlights right here the login. You can see it. Right. So it sees the login and then it highlighted the login page text. So login button and login page text and asserted that they exist. Okay, good. So all of those are built in Playwright locators. Some of the examples that we've seen online, we're doing them right now. So next one, let's do number 3, get by label. And for the label, we need to find labels. So here, let's take a look at password field. You can see there are labels here. Label. So the label is assigned to this input field text. There is a label for it. Okay, let's try that. So I'm going to grab it by the label username. So inspect it. You can see there's a username label. Tag is label, and then there's a value username inside. So let's do that. Await. So here I'm not storing it. I'm just directly going and grabbing. So page get by label. Get by label. Username, and then fill the Tom Smith. So login text will go here, and then the password. If we inspect the password field, again, there's a label for password. We're going to grab it by label as well. So, and put the super secret password in there. All right, and let's give it a run. Not everything. So we want to only execute the locators. Start executing all of the test cases. Okay, and we're rerunning it. Only going with the locators. Let's run it. Okay, so you can see it was able to use the label above the input field and then enter the values inside the fields. Okay, looking good. So these are some of the examples that Playwright encourages you to use. So you want to be using the built-in locators first. Now we can give some CSS selectors. CSS selectors examples. Okay. So one of the most common or used is just by ID, right? And we already know. So for example, if we take a look at the username field itself, there's an ID in the field. So we can use that. And then when you use CSS for ID, you just put in the hashtag. Before the ID, you have to put the hashtag. So it would be await page. Now we use locator. And here I can just say hashtag username. So that would be an ID. And I can fill it. So let's fill it with something different. So selected by CSS, something like this. So we visually will see when CSS is typing the value into this field. Okay. You can also use tag and attribute and the value with the CSS selectors as well. So that would be something like this. So here we're going to say get by ID CSS selector. Get by tag attribute and attribute value. So for that particular example, we're going to take password field. And we're saying it's an tag as input, so it starts with an input tag right here. Then we go names equal password. So name, the attribute name has attribute value password. So right here, name equals value password. And then also we're going to fill select by CSS as well to that. And let's do by radius. I got to move the comments a little bit. Like this. Okay. So the last one will be get by class name. Also CSS. So if I inspect this button that I will attempt to click, it has a class. It has a bunch of classes, multiple. But one, okay, so class is radius for the button itself, not for the information element inside of it with a text login, but for the button itself, there's a class radius. So we can use this class name just with CSS. It will be dot radius for selection. Okay, so we'll do await page locator dot click, but not button, but actual class is radius. So it will attempt to run through this. First, it will enter valid login and valid username, but we will not be logging in with those. Then it will reselect it and enter invalid username, invalid password, and then attempt to log in. So let's give it a try. All right. And here we can see this is where we're using Playwright Locators. So the text got filled in for Tom Swiss and password. Then we selected it with CSS locators and updated the values for the username and password and attempted to log in, clicking the button. Yep, but nothing happened because those are invalid credentials. That's where we stop the test case scenario. Okay, and let's do some examples of the XPath selector examples. So first one, let's just do match by ID, by XPath ID. So it will be very similar to the CSS, but instead of using a shortcut hashtag, you actually need to provide the tag where you're starting, so -- input, and then you provide @id, which is your attribute name, and then attribute value username. So it will be selecting the same username field, but just spelled out differently because now we're using actual XPath instead of a CSS, right? Okay, let's get also by text match. So get by XPath with text match. So that will be using contains. Okay, so await page.locator. This will be a little bit different. So input, we need to, with Playwright, you can explicitly say XPath equals, or you can just start with a route for the XPath. So input, well, actually, let's put a password. So input contains not name, because it was looking at the name. So name password. I don't want the name. I want actual text, but text. Okay, so it's not gonna grab by text because the text is not in the field name. To grab by text, we need to grab the login button. That's the one actually that has text inside. All right, so we're not gonna grab name password. So it contains attribute name with a value password. We're not gonna do that because I wanted to grab by text. So we will change to button, and then contains, remove this whole parentheses, contains text, and the text is login. So I'm looking for a button that contains text login. So this, and then we can't fill anything. So we're just gonna click it, right? .click. So what happens when I provide, I'm gonna update the username to the selected by XPath. Password will still be selected by CSS because I'm not updating this. But when I will attempt to log in, I will see your username is invalid. So let's inspect this. It's inside a div, and it's also text. How can we assert this? So we can also use, we can grab this element after. So we can store it, store text, element by text for failed login, and assert it. So we'll do the same thing that we were doing here when we were storing element and then doing assertion. So we can do await page.locator. And again, when we inspect it, it's a div. So you want to start with // div. then what's inside it, if what are we going to use? We can actually store it by ID flash and then assert that there is a certain text inside of it. So we can say at ID equals flash. Const. So it's going to be error message page locator div at ID flash. Good. So we store the error message, and then we will assert that this stored element inside of it, we actually have a text. Your username is invalid. Okay, so that should get us where we want to be. And let's give it a try. Okay, so there's a problem with the last locator. Some of the code is getting generated as I go, as I type it out, with the help of an AI, and I didn't double check. So, because the text is actually nested, it's not inside the button element itself, but under I, we could either change the element to the I, the tag here to I button, instead of button put I, and then contains text login like this. So let's run it one more time. Yeah, so when you use text, it will only look directly. So contains text, contains text. Text will only look directly into the element itself. So when we were looking at the button, there is no text in the button. The login text in the button itself was nested in the I tag. So if we wanted to do a match without matching the tag I, but just to the button, we need a different search that will be able to traverse and kind of go deeper and look inside the child elements. So instead of contains text, the other way to do it is to do dot. So now it will go through inside the button and go deeper and find the text login with it. So that would be the update here. All right, let's run it, rerun it. And we are all set. So we start, navigate to the page. We find by role button, by role login. We find the text by text. Then we start going with the CSS locators. Then we switch to, after radius, we switch to XPath locators. Selected by XPath, and then we try to log in without a password provided. Found it, clicked. So the username is invalid, is still out there. I think this is from even the previous login attempt with invalid values from the CSS. And it just stays there, and then we assert it. Okay, so all in all, this looks good. So we used here some examples of Playwright Locators, the one that Playwright recommends. And we use some examples of CSS and XPath. So your best bet is just to practice this and type things out. And again, understanding the HTML structure here. What is the tag? What is the attribute? What's the attribute value? And how do you select those? And a good way to getting started is just by using the Playwright documentation and going through the locators that Playwright suggests. All right, so this was Alex USA Days. I hope you enjoyed the video, and I will see you in the next one. Bye. Hey everyone, this is Alex USA Days, and we're continuing Playwright automation with TypeScript, and we're in Module 5, and today we're going to talk about Playwright Assertions. So, Playwright Assertions validate whether the web page behaves as expected. If the actual state matches the expected result, the test passes. If not, it fails, indicating a problem. When making assertions, here are a few common things we usually check. Visibility. Is the element visible or hidden? Text content. Does the element include the right text? Attribute value. Does the element have a specific attribute? Count. Are the correct number of elements present? State. Is the element enabled, disabled, checked? Navigation. Did the URL change as expected? We're going to take a look at the documentation once we're done with slides, but you have the link on your screen. It's playwright.dev/docs/test-assertions. Now, there are some specific assertion types to consider. The default are auto-retrying assertions. Auto-retrying assertions will retry until the assertion passes or the assertion timeout is reached. Note that retrying assertions are async, so you must await them. So every time when you type out an assertion, you should start with await key. Non-retrying assertions, they allow to test any conditions but do not auto-retry. Can be used without await, but most of the time web pages show information asynchronously, and using non-retrying assertions can lead to a flaky test. So if you want to store data and then assert it later, that would be non-retrying assertion. Negating matchers. To assert the opposite condition, simply add .not before the matcher. The matcher is the method used to check a specific condition, like to be visible or to have test. So you just put .not to be visible, and then it means you're waiting for the element not to be visible. And the last one is soft assertions. Normally, a failed assertion will stop the test right away. But with soft assertions, Playwright lets the whole test suite run. And even if something fails, it will finish this test suite and then it will log the failure instead of ending the test right away. So we're going to see examples of this right now after we check the Playwright documentation. Okay, so here we are at the Playwright docs for the test assertions. One of the reasons why I'll keep pointing to the documentation is that the fastest way to figure something out on your own is to go to the documentation and read if you're not sure how to do something or search for an answer here. And it's a habit that needs to be acquired. So just get used to it. If you're trying to find a solution to a problem, when you're trying to automate something in Playwright and you're not sure how to do something, try documentation first. It's a good habit to have, and it will help you out to write your automation. Okay, so here we are in the assertions, and we start with the introduction here. And here we have auto-retrying assertions. So all of those assertions, so to be attached, to be checked, to be disabled, to be editable, to be empty, to be enabled, to be focused, to be hidden, to be in viewport, to be visible, to contain text, to have accessible description, to have accessible name, to have attribute, to have class, to have count, to have CSS, to have ID, to have JS property, to have role, to have screenshot, to have text, to have value, to have values, to have screenshot. That's for the locator and that's for the page. Then for the page to have title, and then for the page to have URL, and for the response to be okay. So all of those say await. So they start with the await keyword, and all of those locators will keep on retrying to pass the assertion until the time runs out. So whatever your default timeout in the config, if within that spawn time it wasn't able to get this element to be visible, for example, or to find that text, then it will fail. Okay. Now, then we have non-retrying assertions. And to be close to be defined, to be falsy, to be greater than. So like comparison operators, to be greater than or equal, to be instance of, to be less than or equal, to be nan, to be null, to be truthy, to be undefined, to contain. Strings and arrays both used to contain equal, to have lengths, to have property, to match object, to strict equal, to throw any instance of class primitive, anything matches anything, array containing, close to, object containing string matching. So all of those assertions are non-retried. So when you use those, when you store some value during the process and you want to verify it later, maybe you're waiting for some other process to finish or there's a set of actions need to take place, then you can store something in the variable and then you can do the assertion later on and then just use expect and essentially you just grab a value from a variable and compare it to something, for example, right? Here are negated matchers. So this is dot not that you add before the matcher to essentially verify the opposite, right? So something is not visible, something does not contain text, and so on. And the last one that we're going to cover is the soft assertion. So you just, after the expect keyword, you just add that soft. And what it means, it will keep on running the test suite. And at the very end, it will still fail it, but it will go through all the steps first. Okay. There are some additional concepts here, like concept of custom expect message, um, expect to pass, adding custom matchers, and so on. But this is to be a little more advanced if you're just starting with a Playwright, so I'm not going to cover those. Okay. So now let's get going with our assertions, have some examples. And once you master those examples, it will be enough for you to get started, to start verifying things and making sure your page is showing what you expect it to show. Okay, so let's add a new file in our test folder. Let's create assertions.spec.ts. And let's start with importing. All right, so in our first test, we're going to have multiple examples of different assertions. So let's say test. Let's do login page assertions. All right, so async page. And first thing that we need to do is navigate to the page. So we're going to say navigate to the herokuapp.com login. So we are going here. All right. So once we navigated it, let's do the first type. So first we will do auto retry assertion. So auto retry assertions is the default behavior and will retry until timeout. Okay. And we will start with the wait keyword because again, it's asynchronous and we have to wait for something to show up. And we do expect. And then you can pick one of the auto retry assertions from the documentation. In our case, let's take the one that says to be visible. So we're going to grab a get page by role button with the name login to be visible. Let's take a look at the page. Inspect it. So it's a button, type submit, login. Let's grab instead header. So we're going to grab heading h2 login page. So going to do heading. So role is heading and the name is login page. So the text at the very top when the page load. All right. The second one, let's do non-retrying. So non-auto-retrying assertions. And it will fail if the condition is not met. So first we can retry, we can assert the same heading, the same element right here. So this text, login page text, h2, but we want to store it first, right? So I'm gonna grab element, store the text of the element, and then assert it. This way, I will not gonna have to use await keyword when doing expect, right? Then doing actual assertions. So I'll say const. Let's do heading text, and we still have to wait for the element to load. So I will say page dot locator, and it's h2 text content. So I will wait for the element to load, and then I'll save the text content, and this text content will be now saved in the heading text. And then somewhere down the line, I need to do the assertion. I don't have to use auto retry anymore. I can just use expect. And we can use, for example, to be. So to be is one of the assertions that is not auto retrying. So I'll put in heading text and then to be login page. So I am still verifying the same exact text, but now instead of using to be visible, I am just making sure that this value login page was actually saved in this variable. Okay. Now let's do negative matchers. So negative or negating matchers. Okay, so when you try to log in and you have an invalid credentials, this element appears, and the alert has ID flash right here. So if the page is just loaded and you did not attempt to log in, the flash will not be there. So there's no error yet. So I can just assert that it's not visible. I can say await, and we will use auto retrying assertion here. So await, expect page dot locator, and that will be ID flash. So we're using the CSS locator here, not to be visible. So we just added dot not before the matcher, before the method that is doing the actual verification, and that's it. That's all you have to do. And the last one is the soft assertion. Soft assertion. And the soft assertion one stop execution. If it fails, it will finish the whole test run. It will not immediately drop everything and abort. So you can say await, expect, let's do, okay, dot soft. And then let's verify the URL. So page to have URL, and the URL that it has login. Okay. So it means that there is a login here inside this URL. And we want to add one more assertion to just to verify that execution doesn't immediately stop when we have a soft assertion. So let's do last check. Just last check. So you'll see it pass. Last assertion that it passes post soft verification. So let's do await, expect, and we're gonna do Okay, get by role button, name login to be enabled. All right, let's try that. So last assertion. Okay, so let's try the set of tests here. We need to close this last parentheses. Okay, the test is now closed. Let's do npx playwright test dash dash UI. So we're gonna run this assertion spec file. Here we have the UI, login page assertions from the assertions.spec.ts file. Let's run it. So hit run. So it goes to the link. So everything passes. Then it verifies that login page is visible with auto retry. Then it stores our text from the same element, login page, then verifies it with non-retrying assertion expect to be. Then it verifies that flash is not visible. Then it tries the soft assertion that URL has the login. And then it tries the last one. Okay, so it did get by role button name login. Okay, and it got the last element and it's enabled, asserting that the button is enabled. So everything looks good. Okay, so now let's fail this. And instead of login, let's say logins with S at the end. So the link is login, so it will fail. But because it's a soft assertion, you will see once the timeout passes, and again, your timeout, default timeout is in the Playwright config, right? So once this timeout passes, it will fail the step and then continues, and you see after the soft assertion, it still verified the button. So here is the assertion of the URL. It failed. You see it's in red. The whole suit, the whole test failed, but it still ran the test step after the URL verification because we have .soft. Now, if I will remove that and instead of .soft, I'll just do a regular expect, and we're gonna rerun the same thing, you will see it will no longer check for the button because as something fails with the regular assertion, it will immediately fail the whole test case without proceeding any other steps further. So let's rerun it. And you see the URL, it's waiting for it. It's auto retrying. Now it timed out and it failed. And you see we no longer do the button verification because there's no soft assertion here. It's just a regular one. And as soon as it fails, the whole test case fails. Okay, so let's bring everything back as it was. So soft assertion and login. So those are the main assertions that you can use. Now, one thing with the soft assertions, if you use all of the soft assertions, multiple steps with the soft assertions, you might also have a final check to make sure there's 0 errors, right? So for that, we'll do test. I'm going to do a new test here, and let's do multiple soft assertions with final hard assertion. So it will be a final hard assertion that verifies that everything looks good. So we need to still navigate to the page. So I'm just going to grab this navigate. Okay, so let's do multiple soft assertions. So first, we're going to do the same exact thing. So await expect dot soft. So login page should be visible. We're asserting that. Let's do a soft assertion that flash is not visible. So dot soft for the ID flash has not been visible. And the last one, let's do the URL. Okay. Also soft assertion. So I have 3 soft assertions here. The final step is final hard assertion, where you want to store all the errors, and you can get errors if there are errors throughout the test case. You can do const errors. Errors. We're gonna store them in the errors $R errors variable, and you can reach it by saying test.info.errors like this. Okay, so if there are any errors throughout the run, they will be stored in the errors. And then we're gonna do expect. So this is non-auto retry and assertion. Errors dot length. So it's going to be an array, and there should be 0 elements in that array. So errors dot length, comma. I'm going to use backtick. So there where and here I'm going to just print how many errors are there. Errors dot lengths, soft assertion errors to be 0. Okay, so let's close the whole thing, and I'll tell you in a second what we're doing here. All right, so I'm gonna go through 3 assertions here. If any of them failed, they will be stored within the errors variable in an array. And then we will take a look at this array lengths, and I'm expecting this array lengths to be 0. Also, I will print out a message saying how many there are soft assertion errors. So if there is 0, it will say errors lengths 0, right? So there will be, this will be coming from the variable. Because I use the backtick, so it's before 1 on your keyboard. If you press shift and the key before 1, it will do this like backtick element. And then you can insert a variable inside the string. So let me do test.only to show you how this works. I'm going to do just npx playwright test without the UI here. So we can see it in the console. Yep. npx playwright test. It's going to run, because I use .only, it's going to run just this particular test. Okay, and everything looks good. I can open up a report, npx playwright show report, multiple soft assertion with final hard check. So here is one assertion to be visible, then not to be visible, to have URL. So all of those 3, 1, 2, 3, they were executed. And at the very end, you have this message, there were 0 soft assertions errors. So this is coming from this last hard check that we put in. So what will happen if there will be errors? For example, we're going to update to have URL logins, and let's insert it somewhere in the middle so we can see the other assertions are still continuing. So I'm going to put it in between. So first it will verify it's visible, then it will verify the URL, and then verify not visible. This line 31 will fail, still going to continue with all the soft assertions, and at the end it will do the hard assertion, trying to make sure that there is 0 failures, 0 errors in this test, and we will see the printout with the message there was actually 1 error. So let's rerun this. npx playwright, let me clear it out, clear, npx playwright test, running. Okay, there's a failure. It's trying to auto retry on the line 31. Timed out. There are going to be multiple retries in the config. Okay, it's doing them. And now Okay, fail. So it expected pattern logins. It got login instead. The whole string is shown here, this whole URL. Okay. Multiple soft assertions. Shows that it failed on line 31. Good. And then here is our final hard assertion. There were 1 soft assertion errors. Expected 0 and received 1. The final hard assertion failed. We wanted 0 errors. Okay, so you will see there is a soft assertion fail that was on line 31 right here. The whole test run still fails because of it. But also at the very end, there is a hard assertion that makes sure that there are actually 0 any errors throughout the whole test run. Okay. So this is it. Type this whole thing out, run it on your own, take a look into documentation into other methods for the assertions that they have available. Try them out as well. And this is it. This was alexusadays. Hopefully you enjoyed the video, and I will see you in the next one. Hey everyone, this is alexusadays, and today we're continuing Playwright automation with TypeScript. We are in module 6, and today we're going to talk about UI visual testing. Playwright Test supports automatic screenshot capture and visual comparison using await expect page to have screenshot. On the first run, a reference baseline screenshot is saved, and on subsequent runs, Playwright compares the new screenshot to the baseline and reports any differences. When performing visual assertions, keep this in mind. Cross-browser or responsive layout. Use visual testing to validate rendering on different devices. Second, stability. Avoid testing pages with frequently changing layouts, for example, under development pages. Third, privacy. Mask or avoid areas with sensitive user information. 4, page rendering. Good to catch misaligned elements, broken styles, or missing images. 5, text-driven content. Avoid pages like dashboards or tables. Small changes can cause noisy diffs. Number 6, functionality versus visuals. Prioritize functional testing first. It's less prone to false failures. There are more details in the Playwright documentation. We're going to take a look into it in a second, and then we're going to type out some tests ourselves. Okay, so here we are on the visual comparisons page. Just type in visual comparisons in the Playwright documentation in the search, and this page will come up. So we can see that in order to generate tests, we can run it for the first time. It will create screenshots, and then those screenshots will be used as baseline for reruns. You can also see that you can provide specific names to your screenshots, and it will run based on the platform. So your project name will be part of the screenshot name generation. You can also update snapshots. So instead of deleting screenshots and generating new, you can just run a command npx playwright test --update snapshots, and it will generate new screenshots for you. There are also some options you can use, for example, like setting amount of pixels that you're okay, would be different, old page, old screenshot versus new screenshot, okay? And you can also provide those settings not only within the test itself, but in the config. All right, so let's generate some tests and look how it works. So we will be using the internet herokuapp.com/login page for this test. But we're going to create new test files. So in the test folders, we're going to go and start new file, and let's call it visual testing.spec.ts. Okay. So our very first step to start it, we just need to import the Playwright. So let's do that. Playwright important, and let's put all of our tests in a describe block. So test, let's call it describe. Visual testing. So I will delete all of this stuff. So we have a describe block here, and let's start with just capturing screenshot in the very first test. So first test to capture the baseline screenshot. Okay, and we will go with test plain screenshot captured of login page, something like that, right? Okay, so step one, we gotta navigate to the page. So we're gonna go to the internetheroquapp.com login, and the second step is just await page to have a screenshot. I'm not going to provide name. I'm not going to provide anything. Just this particular function will run, nothing else. And let's put out in the console baseline screenshot captured successfully, right? After the test run is completed. We need to, it's not part of the page actually. We need to do expect. So await, expect, and then do page, and then to have screenshot. Yeah, so it was not part of the page itself, it's part of the expect. Okay, so now we can run this. I need to close the describe block right here, or the test one, or the other. Okay, so I put a test.only, and there's no screenshot or anything generated just yet. There's no folder indicating any screenshots. So let's run it. npx playwright test. Okay, also before we run this one, let's check the previous ones that we don't have any .only tags, not here. Okay, there's one in the assertion, so we want to delete that. Okay, I think we're good. Yeah. So we're gonna run this test and generate a screenshot, nothing else. Let's go. Test runs, prints out. Okay, so it says it failed, and it should fail on the first run because it says error, snapshot doesn't exist, and then the generated one. So now inside tests, you have visual testing, specs, TS, snapshots, and that's where the screenshot was generated. And you can see visual testing, plain screenshot captured of login page, Chromium Win32. So it takes the project name from the config, so from here, Chromium, and from your settings from here. If you're like on Mac or on Ubuntu, it will generate a different name for your machine. If you have a different project name, like if you have Firefox or something, it will generate two different screenshots for different browsers. Okay, and then it will compare against each browser against the screenshot that it generated for that browser. So it's pretty good for like cross-browser verification or like different screen resolutions. All right, so screenshot is generated, and if we take a look at the test name here, so it grabbed visual testing as the part of the name, so that's your describe block, and then it grabbed the test name here, plain screenshot captured of login page, so it's the continuation of the file name. So you can be descriptive in your test name too, so the screenshot will reflect that. So plain screenshot captured of login page, and then one Chromium Win32. All right. Now, if I'll rerun this after it failed, there is already a screenshot in place. Let's clear it out. Clear out the console, run one more time. It runs. Now it passes. And you can take a look at the report that it generates. Okay, so everything looks good. It matches. No problem here. So run, completed, and it passed. So what happens if your base screenshot is different? So if I'll like right click it and reveal it in Finder, and let's say I'm going to edit it. So I'm going to edit with paint. Here, here's the page, and I'm going to add an X here. Save it. So now my baseline screenshot is different, right? Let me rerun this. Not the report. Rerun the test. So npx playwright test. And it fails. You can see it shows the diff, what is actually different, and it highlighted the X that I put it on the screenshot. Here's an actual image that it just took the screenshot of. And then there's expected, because we added to the baseline, to the golden screenshot, we added the X. And there's like side by side comparison, one versus the other was the difference, right? And the slider where you can see how it changes. All right, so this is the HTML report that's generated when your test screenshots don't match. Okay, let's clear this out. Now, if you want to update your screenshot, without deleting it, you can just do playwright, npx playwright test -- update snapshots. So let's run this. Gonna grab a new screenshots, save it instead of the one that we had, and you see the X went away. So it fixed the test for us. All right, perfect. So this is the first test that just grabbed the screenshot. There's really not a lot of happening except that we're looking at the page. So sometimes page will fit into the screen, sometimes it doesn't fit. When page doesn't fit, you want to have some additional options. So I'm just going to copy paste this block, remove .only, and here for the comment, let's add full page capture, full page screenshot test, and then add here full page. Full page screenshot capture of login page. So we're going to navigate to the page. And then again, we're going to do the screenshot capture. I'm going to remove the console message. And all we need to do is to add option here, full page equal true. If you have long pages that you scroll down, this is a good option for you. So it will grab the whole page, not just what fits into the screen. So let's run this test. So again, it's going to fail first. And visually, we're not going to see any difference right now because I don't think this page is really scrollable down. But if there was something to scroll down to, we would get a full page screenshot. So for your pages with a scroller, if you need to go down to see other parts of it, use that option. Okay, it passes. It generated full page screenshot over here. Everything looks good. Okay, so and then sometimes you need to compare only a certain element. So let's do a visual check of certain element, visual check of a specific element, right? So what we need to do here, again, I'm just going to grab this test. It actually gave me one, so let's do that. Navigate to the page, log in, get role button, log in. So we stored the button here in the variable, in the login button, specific element, and then say expect this login button needs to have a screenshot, right? And let's give it a name. We can give a name to this particular test to be more explicit. So login button screenshot. Okay, no other options here, just the name of the button. And test.only. Let's run this. Again, it's going to fail first. There's no such screenshot. it added one, and now we can rerun and take a look. Login button, screenshot, Chromium. So you can see it when I added a name, a specific name for the screenshot to be saved, it actually dismissed the name of the describe block and dismissed the name of the test case, and it generated the name based on the text that you provided within the method itself, the function. Okay, let's take a look at it. And there's just the button, nothing else. So if something changes with the button, you will get a failed test case for that particular element, and it will show, okay, now it's actually different. And what about if you need to hide some stuff? So on the Heroku app, the internet, there's a username and there's a password field, right? So if I'm typing something in here, I want to make sure that I don't show those elements, right? I don't want to show username or password. If you're testing some sensitive information, it shouldn't be part of the screenshot, right? So you can do that by masking. So masking sensitive information. So test mask screenshot of login page. This is fine. Again, we're navigating to internetherokuapp.com login. Now, how do we mask? So we want to say await page expect to have screenshot, and inside, let me give it a name first. So here I'm going to say login info masked.png. Okay. And let's add some options. So what options I'm going to use? I will say that, first of all, I want a full page, right? So I'm going to add a full page as first option. Second option, I will say mask. And now I need to list the locators. So first will be page dot locator, and let's see what we can use. We can use just the ID for this. So we can use ID username and ID password, right? Here. So username, and there's one here, ID password. So we're going to, based on the IDs, we're going to hide those elements. So page locator, username, and page locator password. So we provided elements to mask here. So mask, page username, password. This is closed. Okay, this is good. This is closed. This is closed. We need to close the describe block. Okay. Like that. Good. So I'm going to delete this dot only and going to add dot only to the last test. Let's clear it out. Let's generate the screenshots first. So it doesn't fail. I'm just going to say update snapshots. It's going to generate a snapshot for the test without failing the test. And now let's run it. You can see here it is login info mask Chromium Windows 32. Okay, just passed. Let's take a look. How does this screenshot looks? And here it is. And you can see the fields that you provided in the mask are hidden. So whatever the password will be put in, whatever the user name would put in, those will not show up. If there's some information in there, you're not going to see it. Okay. Yeah. So that is it. This is how you can do visual testing. And again, it's important to understand that those tests can be fragile. So you need to configure them in a specific way so they don't fail. And it's better to automate pages that are consistently represented in the same way. If there's a work in progress and the UI gets updated a lot, those will fail quite often. All right. So rendering pages, stable pages, pages across different devices and screen resolutions. You can have like a high level check of a landing page or something that stays stable, work is done, and you're pretty confident, this is how it should load on the updates. Focus on the functional testing and have your visual testing added to it later. All right. So this was alexusadays. Thank you for watching, and I will see you in the next video. Hey everyone, this is alexusadays, and we continue Playwright automation with TypeScript. Today we're in module 7, and we're going to talk about accessibility testing. Accessibility testing checks whether a website or web app can be used by everyone, including people with disabilities. It is both a design goal and a technical requirement. Accessibility compliance is mandated by law in many countries. In the USA, ADA Section 508 ensure equal access to information and technology for people with disabilities. Organizations like Google, Microsoft, Apple, and banks must meet accessibility standards. Many other organizations have to meet them as well. A11Y is a numeronym for accessibility, where 11 represents the number of letters between A and Y. So it encompasses all types of accessibility within it. WCAG stands for Web Content Accessibility Guidelines, and it is part of A11Y because 11Y accommodates all of the accessibilities, voice accessibility, visual impairment, everything. WCAG is specifically for web content. It is a set of rules, standards, recommendations that define how to make content more accessible, especially to people with disabilities. A lot of companies use WCAG, AA, or single A, and sometimes triple A. It's a different level of implementation of the rules, where AA is pretty much a standard. So they use these recommendations as a guideline to implement accessibility for their web pages. It is one of the most popular guidelines out there that is implementing, that people use to implement accessibility testing for their products. Now, Playwright supports automated accessibility testing using the open source library called Xcore. This same engine is used by Chrome Lighthouse, one of the manual tools that you will find in DevTools, to run accessibility tests on a web page. This ensures consistency in accessibility testing tools. We're going to look through the pages for all the documentation, can have a brief description what is what, and then we're going to write some code. Okay, so let's get into it. Okay, and we start with the accessibility testing, the Playwright documentation, where it talks about installing the package that adds the support, so Xcore Playwright. It also talks about the disclaimer, so that accessibility test automation can detect most common problems, but there's still manual testing required. So a lot of things will be done through the manual testing. It's not always a good idea to rely on automation to do accessibility testing completely because of all different things that can come up during the testing, right? And you can see that we import the X builder once we installed it. And then if you run the testing, you can do X builder, your page, and then .analyze. So if you do .analyze, it will run everything that the package has. So this is more of like your A11Y, so accessibility in general, impaired vision, voiceover, and many, many other different things. So everything the library has to offer. And then once the report is generated, you will get into the report in the section violations of it in the file .violation. So you access it specifically. You want to see that there are 0 errors. Okay. Well, one thing was that if you do just .analyze without specifying what kind of accessibility you're running, because it's going to run everything, you might find a lot of issues that are not relevant to you or your product. So typically, this is not the best way to go. The better option would be is to provide specific tags. And here we have WCAG, which is a web standards, right, for accessibility. And you got level 1A is a minimum level requirement. 2A is the standard. This is 2 older versions of WCAG. This have to be supported now. WCAG 21A is the minimum required of the upcoming next version, and WCAG 21AA, or essentially this is 2.1 and this is 2.0. So let's call it 2.1. So this is the standard requirement. This is the minimum, this is the standard, and this is upcoming. So that is something you will typically see or use if you're doing web testing. Okay, so there's some more description of what is there and what is not there, and how to disable certain things. So for us, we're going to have a kind of a generic coverage that will cover the WCAG and some of the specific configurations of the testing. Okay, now to Web Content Accessibility Guidelines. So this is the page that has all the guidelines. You see the version 2.1, and the recommendation is May 2025. So there is 2.0, which you saw in the tags. Then it has all of description, what is supported. And I mean, you don't have to read all this. There's a lot of information. But when you need to dive into some specifics, you can find it in this documentation, what should be there, what should not be there. Another way to kind of understand it better is just go and read Wikipedia on accessibility and web content accessibility guidelines. And over here, you will find what kind of guidelines were first, so like version 1, version 2, and you can see what is considered success criteria for a specific guideline and what was added. So like non-text content, sign language, auto description. And so it has to be principles, has to be perceivable, operable, understandable, robust, right? So different concepts and how it was implemented in different countries and what is current support. So like this is a lot of information, but our focus is not going to be on accessibility per se in every kind of aspect of it and what should be there, should not be there. We have a tool that does a lot of checking, and we have a company that's called the Q, I guess, and it has this open access accessibility testing tool, and that is the same tool that is used in Chrome. So if you go into the Chrome tab, or maybe not the same tool, but more of the same library. So if you're in Chrome and you do inspect and you go to the Lighthouse, so whatever you page on, there's a way to run accessibility within the DevTools itself, and that's going to be more like of a manual run. So if I'll go to Heroku app, the internet login, and I'll run accessibility. Let's do like desktop version. Run it. It will give a lot of different suggestions if the alternative text is missing, if the headers are not properly set up, if some things are missing in the tags or in the elements itself. Here's a notice from the accessibility: background and foreground colors do not have a sufficient contrast ratio. Fail in the elements. There's a lot of things that accessibility showed here. So not a perfect rating, 89. Your perfect would be like 100. So this same tool, the library that Playwright is using, or the package, is the same exact thing, right? So there are different configurations that you can set up to it, but it is using the same open source that was done by this company, deque.com X. So give it a read, explore the webpage, just listen to me like for a general understanding of it. And here is this Xcore library as an NPM package. Now this can be used as a standalone package for your testing needs, right? Through the NPM. But we're not going to be doing it as a standalone. We're going to be doing it as a part of a Playwright. Okay. So now let's go ahead and write some code. We're going to create two files. One going to be like the basic asserting everything that it has to offer out of the box. And the second one going to be a little bit more complex, but we'll try to build an actual report in there. And we will be asserting login page at the herocoop.com login. So if we go to the inspect, we go to the lighthouse and we run accessibility here. We will see there are a bunch of errors coming up. So we got 89% completion of accessibility, and you have the contrast issue, navigation issues. So there's some things that are not accessibility friendly on this page. All right, so what do we need to do? Well, first thing first, we need to install the same library that the Lighthouse is using to the Playwright. So we will do npm install at x-core/playwright. Okay, so when you run the installation, then you can go to package JSON and make sure it is now in dependencies. So here we have it. So now once this is done, in our test folders, we're going to create new file and let's call it first_accessibility.spec.ts. All right, so that's going to be our first file. Over here, we need to import test and expect from the Playwright, and we also need to import xbuilder from the package that we just installed, Xcore Playwright. All right, so now let's create a test and let's do test.only. So just that test runs, and let's call it general accessibility checks. So we're doing here, what are we doing? So we're navigating to the herokuapp.com login, and then we run accessibility checks. This will create new xbuilder and then run the analyze. And by default, whatever the xbuilder, the default configuration, default testing, everything is going to run. All the accessibility checks it has to offer and configured by default going to run, and then the results will be stored in this variable, accessibility scan results. Now then we can log it and we can see all the scan results, and we can also assert, once we logged it, that inside the scan results there is a violations section, and the length of it should be 0, so no errors. Let's run it. npx playwright test. So this is generic run, has all of the rules for accessibility, and we see it is failing. We found 5 issues. So Xcore from the default configuration has a lot more testing that is set in Lighthouse in the Chrome, because everything is running, like everything it has to offer, all of different accessibility checks. Some of them might not even apply to you, like might not be relevant to your product. So usually, and we're going to do that next, you want to configure specific tags to run. And why I printed out accessibility scan results, so you can see it actually gives you everything that it ran in the output in the console, everything that was stored in accessibility scan results variable is in the output, and you have like passes, What else we have here? What are those? What are those? I'm pretty much looking for violations. So we saw passes, and this is something else. Not sure. In inapplicables, okay. So what we really want from here is to get the part of it that is actually violation. So here it is. So in this JSON file, this JSON report that it generates, there's a section violations. And we can access it by doing a dot notation. So accessibility scan results dot violations will just access this particular section of the report, and that's what we need. So we can put in the console log only violations by saying accessibility scan results dot violations. So let's clear it out, run it again, and we will see now the console log showing only violations. We're still going to get the failure and everything, but now the output here is pretty clear. Okay. So there's scan results, and all the violations are showing. The section of violation is showing. So the color contrast, heading order, landmark one main, and you can see all different tags that are applicable to this violation. We're mostly interested in WCAG to AA or anything with WCAG because this is pretty much our baseline for accessibility for web applications, right? And there's a description of violation. So again, when you run everything, a lot of the things that you're going to get might not be relevant to your product. So what do you do with this? We're going to leave this as is. We found there are 5 violations with the default configuration. Let's add another test case, and I'm going to just copy this whole thing, remove .only tag from the first one. And let's now create a test case, and we say custom tags verification. So we're doing the same thing. We're navigating to the page, but then when we start building our accessibility scan results, when we start building it, we're going to give it some rules. And let's maybe just call it X builder. So it's not going to be results yet. We're not going to run analyze with it. We just say results, or we're going to say X builder, new X builder, correct. X builder equals new X builder. Builder equals new X builder. And here we can start giving it some option. So we can say with tags, and the typical tags, again, you will have to talk with what you want to test. But if you're doing web accessibility, it will be your WCAG to A, WCAG to AA, WCAG CAG 2.1A, and WCAG 2.1 AA. A is minimum requirement. AA is the standard. So, and this is what you should be covering. Now, also, sometimes you want to look only into specific tests within those rules, and you can narrow down it even further, which might not be the case for you because running just with tags and having everything those tags have to offer is good enough. Normally, that's going to be like your standard run. But let's say you want to narrow down even more, and then you can say with rules, and then you create some rules. So you want to do only color contrast test. Maybe you also want to do image alternative text. Maybe you want to also make sure that there is a link name. You want to test the document title, something like that. So there could be different rules that you might set here. Now this is something you will like discuss with your product owner, product manager, with your developers, QA manager. So whoever will help you out with building this test suite. So now this X builder is with all the set of rules is stored in this variable, and I'm not going to do that analyze in here. So now I can do another variable that will be accessibility scan results. Now I'm going to use this X builder with all the rules that we set, and then I will run that analyze. Now this .analyze is no longer a default run. It will encompass all of the rules and set of rules that we had here. We're also going to print out violations, and we will say how many violations we have in the end with the expect. Okay, so let's clear it out and run it. And you will see that number of violations, we had 5 before with the default runner. Now it's only showing 1. So once we narrow down the scope of our accessibility testing to a very specific set of rules, the violation that we have now is only 1 violation. And then what it is, we can look in our console log, and it says it's actually color contrast. So foreground and background color meets WCAG to AA minimum contrast ratio thresholds. Okay, so great, but it didn't. So this is like the baseline. You can plug it into your automation. It will run accessibility, and if it fails, you have this, failure coming from the X. That is great, and that's pretty much it. Like you can make it part of the pipeline. But how do you report this, right? So if something fails and you need to figure out what kind of element, it actually hides here in those objects. Like what kind of element having this issue of the color contrast, what developer needs to fix, because you'll have to have it as a part of a bug report, right? So let's do this. I'm going to copy and paste this test. And let's rename it now. Rename. So we'll call this second accessibility spec .ts. Okay, now we don't need the first one, the basic, and we're gonna do more things with this. So first of all, again, the rules are optional. Like your standard would be to run with all of the tags. So I'm going to just have the tags, and whatever rules applicable within those tags, I'm just going to have it as is. Yes, close it out. No rules. Don't suggest rules, just the tags. Yeah, you can specify rules if needed, but that's okay. So let's say store the results. So it will run with the tags for WCAG, and then it will store the results here. That is great. One thing that we're looking at when we run it, okay, I need to actually delete another .only tag in the previous set. So previous test. So second accessibility will have only only for the test runner. So let's run it. It's going to run just this test, only those rules, only those tags, and all the default rules that apply to those tags. Here's our report. One thing that I want to get rid of, like this step, shows a bunch of different tests running that are configured or run by Xcore. I want it to be all one single step, like, because that just matters, just this one. So I want to narrow it down to a block. How I'm going to do this, I will put it in a step. So I will say await test step, run accessibility with custom rules. And then let's close this. And we're going to place everything that we have here. Command X to copy, and we're going to place it within the step. So that's the first thing I'm going to do. So now when I rerun it, we will see that the whole accessibility test run is part of one step, and when you expand the step here, it failed, the accessibility failed, and then once you expand it, you will see all those configuration that Xcore is doing for page evaluation, everything here inside. So a little bit cleaner representation. So this is the first thing. Second, now we want to somehow access like what is the problem, right? What is actually broken? So how can we do this? So first of all, let's store the report, right? And how we can store the report? We can say const report lines, and we will tell TypeScript that this is actually going to be an array of strings, a string array. We're setting the data type that goes into here into the report lines. And now we're going to start logging the results. So log the results. And we're going to say if accessibility scan results, hold on. So if accessibility scan results has lengths of the violations greater than 0, let's start doing all of the different reporting here. So first, it will go and push into the report lines accessibility violation found string. So this line 26 will start our report. It will push, then for each violation, it will do a for loop. And for each violation found in the accessibility result violation, it'll start generating report. We will say report line push violation.id. So we will see the ID of the violation. Then we will push in the report lines violation.description. So what kind of violation it is. Then we will push what is the impact of that violation. So on line 30. Then we will start another for loop within it. So for each node, there could be multiple different nodes that failing for that particular violation. We're going to loop through them all. And we're going to say, what is the node HTML? So this is pretty much what is your locator that is doing the violation. Then we're going to push the failure summary and the node selector joined by space and the comma and space. Okay. If there are no issues, we will just log no accessibility violations found. So this will be a logger, and then we need to store this somewhere. Like we're no longer printing in the console. We have the report. This report needs to go somewhere, right? And what we can do, we can actually write it into a file. So for that, we will need file pass. So let's do const report file pass. And where we're going to store it, let's create a folder first. Let's create a folder and call it accessibility reports. So the name is whatever you want, but let's call it accessibility dash reports. Okay, so this is where all of those reports going to go in this folder. So that will be part of the pass. So accessibility report. So I'm grabbing the name of the folder. So accessibility reports, that's going to be the folder. And we will call it accessibility report .txt, right? So that's going to be the file pass. Now we need to actually write it in. So await. And for that, we're going to use fs library. So fs You will have to import it. So fs dot promises dot write file, and we will write into the report file pass, we will write the report lines that were stored in this variable. Right? So in this pass, we will write everything that we stored in the report variable here that was generated through this process from line 24 to line 39. We will separate it. It doesn't have to be UTF-8. I don't think that matters. But we will separate it by a new line. So join by a new line. So every new line will be joining line by line, essentially, on a new line for every line generated here. One problem, you see it's highlighted, cannot find fs. So fs, you need to import this, right? So go and do import asterisk as fs. So we're essentially reporting everything as fs from the fs library. Okay, that is done. Now our fs has no errors. It will generate report and it will store it in the accessibility reports. Okay, let's clear out the console. Let's run it. Okay, and we have a report generated. Let's take a look. Okay, and now we see that accessibility violations found, and this is the report coming from here, so we can see it side by side. So if accessibility is length is larger than 0, and we found some, right? Start pushing this text into our report line. So first line, accessibility violations found. Here it is. Then the violation ID is added. So violation ID is the color contrast. That's the problem that we're having. Then we have a description, and it says what it is. Then the impact level is serious, and then we have a node, and you can see HTML I class, and then the login. It seems like login button, and then it says impact. After impact, we have failure summary. Fix any of the following. An element has insufficient color contrast, and node selector is I. So the tag is I right here. And then it looped again, and then there's another element with the same violation, with a target underscore blank. Okay, let's take a look on the actual web page. What are those violations that we see? So we're going to go into the elements. We want to find where exactly the violation is happening, right? So we can report in the bug saying, okay, this element is breaking accessibility. So I am in the elements, and the very first class is like this class right here. FA space FA-2X. So I'm just going to copy this text, and I'll do Control F to start search. Find by string, selector XPath, and paste it here. And here it found one element, 1 out of 1. So I highlight the element. So the violation, the element that is violating accessibility testing for the color contrast is actually the login button. So that's the first one. Here's another node or another element with target underscore blank. So let's find underscore blank in the element. So Control F, paste underscore blank, and here it is. This also violates accessibility. The actual link elemental selenium is also color contrast is off. Okay, so and then you can put this information in the bug report. But what if you have multiple runs or that runs on the different days? How can you actually Because if I rerun it, it's just going to overwrite this report. It's going to just create a file, again, report lines, and then it's going to write it down again in the file, accessibility report.txt, and the old information is going to be gone. So how can we do it in a way that we have pretty well timed reports, right? So for that, we can actually add a timestamp, and the timestamp will be part of the report. So to do that, let's, like above the report file pass, let's create a get current timestamp and format year, months, date, hour, minutes. That is good. So we'll create a timestamp, const timestamp variable, and we need to do new date to iOS string. And we will slice it. So from the first character to the character 19, we're going to replace the T with underscores. So we'll have an underscore here for the time instead of a T. And then we're going to replace commas with dashes globally. So here, here, and here, instead of column, we'll have dashes. And the last thing that we need to add, we need to make the timestamp part of the report. So just like that. Report underscore $, in parentheses, we have a timestamp right here that we generated. Make sure that your report file pass is in backtick, right? So you can insert this variable into the string. And now let's run it. So clear it out and run it. Now we have nicely timed report with a date and a timestamp. And the only problem here, now we have 2 reports generated. You might ask, why do we have 2 reports? Is there a problem with the loop or something happening? So actually the reason for 2 reports is because we're in Playwright config. If there's a failure, it does a retry. So CI is the first one. We don't need CI. We don't run in the CI. The second one, when you run it in the local environment. So number of retries for the local environment, if you're doing accessibility testing, set it to 0. Otherwise, you'll generate 2 reports here. Okay, let's go and delete all of the reports in the folder. And let's rerun it. Rerun this whole thing. npx playwright test. We'll run our .only custom tags verification. Here we have a failure. Accessibility should have been 0, but we found 1 issue, and we can see what that 1 issue is in the report. And the issue is color contrast. Ensure the contrast between foreground and background colors meets WCAG2AA minimum contrast ratio threshold. So you can open a bug with all this information. And now there are 2 elements that fail this accessibility setting. So one is the login button, this right here. And the second one is the link at the bottom for the Selenium. So underscore blank and this class FA space FA2X FA dash sign dash in. Okay. So you can open up a bug with all the details on accessibility testing, and then developers will have to fix it. So by doing this, you can run accessibility on after release as part of regression or as a separate test, so you don't have retries, like a standalone thing that you run on your own. And if anything is found, you generate a nice report, and you can use this report as part of your bug creation process for this. Okay, so that's it on accessibility testing, automation accessibility testing with Playwright. And I will see you in the next video. Bye. Hey everyone, this is alexusadays, and we're continuing with Playwright automation with TypeScript. And today we're in module 8. We're going to talk about Playwright API testing. So API stands for Application Programming Interface. In web, API is a set of rules and protocols that allows different software applications to communicate. API allows web browser or client to communicate with the server. And this is a high-level diagram where you have a client, your browser, your mobile phone or app, sending request to the server using the API, and then the server responses back. And this is how the communication happens. One of the most popular API approaches is REST. REST stands for Representational State Transfer. It's a type of web API that follows a set of architectural principles and constraints. It is designed to create a simple and standardized way for software to communicate. REST API uses standard HTTP methods to perform actions on resources. HTTP stands for Hypertext Transfer Protocol. It is the language that web browsers and web servers use to talk to each other on the internet. The primary HTTP methods are GET, used to retrieve data from a resource, POST, create a new resource, PUT, update or replace an existing resource, delete, remove a resource, and patch, partially update a resource. With an API request method, there is response with a status code. HTTP status codes are 3-digit numbers returned by a web server in response to a client request made to the server. They provide information about the result of the request and help both the client and server understand how to proceed. Response status codes and examples, and this is not a full list, we can take a look at the full list later on developer.mozilla.org. So if it's in the hundreds, it is informational code, such as 100, which is continue, or 101, switching. If it's in 200s, that means it's some form of successful response. When you get a resource, you'll get 200 OK status code. If you create a resource or post a resource, you get 201 create status code. 300s are redirectional messages. So 300, for example, could be multiple choices, or 301 resource moved permanently. 400 are client error responses. So 401 would be unauthorized, and like all of you, so 404 at some point where the web page could not be found. And then 500 responses are server error responses. So like 502 would be bad gateway, or 504 gateway timeout. So this is when you're in the web browser and you accessing a website. If you go to the networking tab in the DevTools, you will see the communication between the browser and the server. And this communication, this is where you can look at the APIs in action. There is a headers tab on a particular request, API request. In the headers, in the general part of the information, you can see the request URL, or essentially API endpoint. This is where the browser is trying to reach the backend for the API. Then you will see the request method it is doing. Is it get or post or delete? Then you will see the status code. If everything looks good, the resource was, the web browser was able to get the resource, you'll get a 200 OK. You will see the headers details, both request and response headers within the header section. Then you have a couple more tabs there. One of them would be a payload, and this is your request body. Data sent, if any. So in the payload, if you create something or you do a post or you update something, you might send some data to the server in the body. Could be a JSON or some other format. And then if something comes back, you will see a response. There's a response tab where you will see raw response data, or there's a preview tab that you will see response data formatted. So when testing APIs with Playwright, the main objective is to implement and verify various types of requests, such as get, post, delete, or others. The process typically involves the following steps. So implementing the request, create and send the API request using Playwright, specifying the necessary methods such as get, post, delete, headers, parameters, and body data as required. And then verifying the response coming back from the server. That would be your status code. So ensure that the response returns the correct HTTP status. That would be the data. So if the response includes data, verify that the data is correct and matches the expected values. Error handling and edge cases. So test various edge cases and error conditions to ensure the API handles them gracefully. This includes sending invalid data, missing required parameters, and simulating server errors to check if the application responds appropriately. One of the most important parts of API verification is documentation compliance. Make sure and compare the actual API response against the API documentation to ensure that the implementation aligns with what is specified in the docs. This includes verifying endpoint paths, required parameters, response formats, and error codes. Okay, so now we're done with the introduction. Let's go and create some API tests using Playwright. So in our folder, test folder, let's create a new file and let's call it API underscore testing.spec.cs. And in here, we will start adding our tests. And the only thing that I wanted to show you before we go, so we will be doing it on res.in webpage. So on this webpage, you have some examples of the API. So if you'll go into the inspect and the network tab, there is get methods and post and put. So if you click on one of those methods, it will execute the API. So the front end will send the request, or the client the send will request to the back end. So I say get list users. It sends a request and then gets a response of all the users. And in the network tab, you can see an API call happening that it's get, and it gets users, goes to this particular endpoint, and you get a response back. So it's a very nice way to test API automation and kind of figure out if it's working or not, what you implemented here. Okay, so we will be doing the testing on res.in. And if you want to know a little bit more about status code and different methods, go to developer.mozilla.org and search for HTTP response status codes. You will see all sorts of different codes that are possible. But the most important thing is to remember that hundreds are informational, 200s are success, 300s are redirection message, 400s are client error responses, and 500s are server error responses. Okay. All right. Now, here we're at res. Let's start implementing. So let's first try and get all users. So we're going to ask this API to be executed by Playwright. So if I'll go and look and click on it and go and look at the request, I'll see there's a certain endpoint. So a link it is trying to reach. It uses get method. There's an API key in the header. So you want to use like an authentication API key for this. Then there's a response coming back. So I can execute this request in the Playwright, get the body back of all the users, right? The request, the response body, and verify that the data is accurate, that everything here looks good. It's matching what we expected to match. Okay, so first thing first, let's start with the import. So I'm just going to import test and expect, copy it from another file, put it here in API testing.spec. And let's put everything into describe block. So I'll say test, describe dot only. So I want only this describe block to execute. Let's call it API testing, right? And the very first one, we're going to get all users. So get all users and compare to a saved response. Okay, that's good. But the problem is I don't have a saved response, right? So I need to store that data somewhere before I can test that the data is actually what it's supposed to be. The response I should be getting is this response right here, this whole thing, right? Or if we look into the response body. So here's the response. This is the request that went out, and it got the response in JSON, all of this information. And this is page 2. We're looking at the page 2. All right, so let's grab this. So let's copy the response body, we're going to be verifying that this body comes back. And we can verify and test against the file, right? So we probably need to create a test data folder. And let's go into our root and create new folder. Let's call it test data. This is where I'm going to put the response body. I'm going to create new file. And this is rec res users page 2 response dot JSON. All right, so we created test data request response underscore users underscore page 2 underscore response dot JSON. Okay, so this is a response body that we got from the web page when we were requesting all users information on page 2. Now, once we did this, let's import the file. So let's call it import page 2 all users. So something very explicit from, and now we need to start from the top of the root. So 2 dots / test. Does it see it? 2 dots / test data / request response users page 2 response dot JSON. Okay. So this file, page 2 all users, is actually the one we will be verifying. Right here in the expect block. Okay, let me close this test. Close the describe block too. Okay, so here we go. Here's the describe block. Inside the describe block, this is the first test. So what it will do, it will get all users and compare it to the save response. Get all users match save response. So first we go into the page, request response in API users page equal to. So this is the endpoint, right? Where do I get this from? You would get it from the documentation, but in this particular case, I just get it from the headers from the actual API request in the networking tab. So the request URL is your endpoint, okay? So we have that, and we're gonna use get method. So the same one, request.get, the same one we see here. So it's a request get method, and we're getting data from this URL, this endpoint right here. Okay, so we have await request.get, and we provide the endpoint link. Then we want to verify the status header. So first, let me just print out the whole response. Await response.json. So since it's a pending promise, let's actually have it with await. Okay, now once we got the await keyword for the response body to come back, we get all of the information here inside the JSON. So everything that we've seen in the response over here online is actually coming back, and we can access it, right? Okay, so now once we print it out, we see what's coming back. We see the status code, we see the response body, we see some headers. So everything, we got everything coming back. Let's start verifying it. So first thing, we will verify status from the headers. And how do we access it? So we go into the response.status, and we want it to be 200. So expect response status to be 200. Next thing that we want to do is we want to parse the body so that it doesn't come like an object. I want to access a specific part of the body, and I want to get into the actual response itself, into the data. So cons body equals await response.json. And then we want to compare the body that we receive from that request to the one that we saved. So we're making sure everything we have is matching. There are no errors. We actually get the response that we wanted. So I want to say expect the body the one that we saved, to be equal to page to all users, right? Page to all users, because we're grabbing the users on the page 2, and we already saved it in the test data in the JSON file. And now we can give it a run and see what happens. All right, let me clear out the console and let's run it. Yep, and it's passing. So we verified that the test data file with all the users here is actually matching what we receive from the this URL. Now, if I'll change something here in the test file, just to show you how it fails. So instead of Michael, I will have here Mike. So first name will be Mike instead of Michael. Let's run it. So the test data now is different. We did an update, and here is a fail coming back into the console. We can see that we expected first name Mike, but instead received Michael. And you have a test report also saying this right here. So expect equal to failed, and it shows what actually failed. So the first name, it wasn't what we expected. We received something else, right? All right, let's update it back. How it was. So there's no failure. So it's Michael, everything good. Clear it out. All right, one more time. And now it should pass. So this way, if you have some static responses that you expect all the time to come back, you can save them and then test against them to make sure that nothing changes, everything looks good. All right. So that would be getting all the users and verifying them. It's the first test here. Now let's do within this block a new test, and we will get only one user, not all of them. Get one user, and we will do field by field assertion. So we're going to do test, get single user, check fields. Again, we need to go and grab a user. Let's take user 2. How do we do that? If we look into the request response, so here's get a single user. I'm going to clear out the networking tools. Here's the request. I click on it. So users dash and the user ID, user number 2. And this is what should we get. We should get Janet, Weaver, her email, her ID, some support information. And here's the actual request in the console. And here's the response, right? So this is what we're going to see, and we want to go field by field and verify that data is correct. Okay, so by doing the request, const response await request get and the endpoint for the user 2, we're going to store all this information inside. Then we're going to extract the body of the response and store it in the body variable. So first we can do response status to be 200. So status code should be 200. The ID should be 2. Yes, we can assert first name, last name, email. We can assert avatar. Everything that comes in the body we can assert. So let's do the email. Email to be Janet. I'm going to copy it from here. So it's going to be Janet. Name Janet. Data last name Weaver. Okay, I think this looks good. And let's close it. Close the test. Now let's do that only for this test, nothing else. That only. And I'm also going to console out, console log the body so we can see the body in the console. Let's clear it out and let's run it. npm run test. Okay, so here's the response body that we saved. And we did then assertion and it passed. So we verified that the status code is 200. The data ID is 2 right here. The email is matching. The first name is matching. Last name is matching, and so on, right? If we wanted to access something in the support, so we would say expect body data, not data, expect body dot support. So this is one block or one array, one object data, and here's another object support. So we can say body dot support, and then we can say the text. Let's verify the text is correct. And the text needs to be tired of writing endless social media content. Okay, so grab this right here and verify it. All right, let's run it. Everything looks good. I'm gonna console out the console log, comment it out. And here, let's make a mistake. So tired of writing. Let's say there's a typo. Tired of writing. So I expect something different. And I see there's a failure. And it highlights what actually failed. So we expected tired of writing, but received tired of writing. Right here. Okay. Update our test. Clear it out. Run it one more time. And it passes. All right, good. So we have two tests to verify our API. One is for all of the users. For this endpoint, users page 2. And the second one is just for one user with ID 2. Let's do one more assertion here. And let's create a new user. So post, create new user. Create a user. And how can I create a user? So that's going to be a post request. We're going to come back in request response. There is a post request. I can create a user. I hit create. I provide details. As a response, I get 201. Here's the call. Clear it out one more time. So post, create users. Okay, so now it's not a get request. We can see in the headers, it's a post request. So we're creating some data. We get status code 201, confirming that the data was created. There is a payload that we're sending. So we're sending the name, first name and last, and the job. And then we get a response with that name being created, job, title being created, ID assigned to a created user, and the timestamp when the user was created. Okay, so we can test the post. Another thing in the headers you will see, there is actually X API key. So you need to pass along explicitly that key, otherwise you're not going to be authorized, right? So we can do that. We're going to have post create user. We're going to create John, leader. It's reaching to API users endpoint with a post method. So now we're saying request post to the endpoint, and we're passing the new user data stored in the new user variable right here. And we're passing a header inside the headers, and we're passing X API key, which is request response free v1. So this is something that is required by request response. You have to pass an actually authorization key or API key in order to create a user. And then we want to verify that the name that got returned in the response is equal to the name that we provided. So we will say expect response body dot name. So we store the response body inside the body variable. We extracted that name, the variable from the body, and we want this name to be equal to what we passed here, new user dot name. So John, as we send it out, should be created and returned to us. We're also verifying that the status is 201, so the same that we've seen here, the status code. And we want to verify that the job is what we actually put in. So let's call him QA engineer. Okay, let's do test.only for this one. So it runs only this test file. Remove the previous .only. And we need to close the test parentheses. Okay, let's clear it out. And run it. And everything looks good. Everything's passing. So what if I, instead of passing along what I have in the variable here, new user.job, what if I'll call it a string and I'll say Sam or something, right? So we said we want to create a QA engineer, but I'm verifying should be Sam. Again, when I look at it, we received QA engineer, but we tried to verify Sam and it failed. So it did not match. The response did not match the expected result. Let's turn it back. Okay, so what's happening on line 36 to line 41? We store in the variable what's coming back from our post request. So we said we're going to do a post request here, await request post to this endpoint, HTTPS request reqres in API users. And in the post request, we're passing load data. And the data is, it's a key value pair. The value for the data that we're passing is the new user variable right here that we created. So in the data, we have name, that is John, and job, that is QA. It's right here within the new user variable. And then in the headers variable, we're just passing the authorization X API key. And that becomes part of our post request. So the request is being sent, and the request gets the response right after being sent. This response is now stored in response variable on line 36. Then we extract the body from this response. So response.json saved now in variable body on line 43. And now we start our assertions. We get the status code. We get the name from the body. And then we compare it with the name that was originally created and passed along in the new user variable. And the same thing for the job. Okay, so that's our post assertion. All right, now let's do number 4, which would be put. So we're going to update an existing user. So test put update user, and we're going to update. We're going to pass updated user variable. So name will be Neo, job will be the one, and then we're going to store again response. And now request we're sending it has .put method. So put is an update, and we're updating user number 2. For the data, we're passing along updated user, and we don't have to pass it as a variable, right? The format how you pass along data is something you're going to look into the requirements for the API. You will see it in the docs, and if you want, you can just pass it like this, like so, as an object. So instead of a variable, you can directly say, so inside the data, we will have a name and we will have a job key value pair, and that's going to be our data object, right? And then it also will pass headers, and inside the headers, we'll have an API key. So either way is fine. Sometimes just objects could be pretty big, so maybe it's a good idea to store them as a separate variable and just pass the variable. So now we're passing update to the user number 2, and we're updating the name to Neo and updating job to the 1. And then we will store the response coming back, and we want to make sure now we don't have an object anymore, variable that stores our values, so we'll have to provide strings instead. So the name will be Neo, that's coming back, and the job will be the 1. All right, let's close the test. And let's do that only for this test as well. I'm gonna collapse the previous tests. Okay, test number 4, only that gonna run. And let's also console log .body so we can see it. I'm gonna clear out terminal and do npm run test. It's running. We see the response body coming back, and it's the name is updated to Neo, and the job is updated to 1. We updated user with ID 2, user number 2. We'll go look for the user number 2, what it was originally. Single user, user 2, it was Janet Weaver. But then we issued the API request and updated her to Neo with the job title, the 1. Now, why it's not reflected on the web page? Well, because the web page resets the information. So the way it does it, like if we had a real server, we would obviously save this and the information would be updated via the API. But because this is more of a training API, the session doesn't actually store the results. So it's a temporary response. But whenever you do a new pull, everything is reset to the default here on request response. That's why you don't actually see an update to user number 2. It's still Janet, and you don't see the job title here just because that's a training data. There's no actual update on database. It just sends you the new restore data, and this is if it was a real API in the real backend, then it would have actually updated your database with this information, right? All right, let's do a last one. So number 5, let's try and delete some data. Remove a user, and let's call it delete user. And I'm also going to collapse this test number 4, remove that only. So when you delete a user, all you really need to do is send a request with delete method. That's it. We still want to save the response. So I'm going to save the response. And I'm going to send request to delete user, and I'm deleting user number 2. You can see in the endpoint here. And once the delete request is sent, I need to pass along the API key. Let's see what happens if I don't, just to see how the API will behave if there is no header to actually delete. Okay. And we need to close the test right here. So curly brace parentheses, the test is closed. So I'm sending a delete request to this endpoint without providing API key. I'm storing it into the response, and let's do console log response status. Clear the console and npm run test. 401. Why do we get 401? Well, 401, do you remember the code? 401 status, what does it mean? 401 status code, also known as unauthorized, indicates that the client browser application is not authorized to access the requested resource. So if you don't provide in the request, in the delete request to delete a user, right? So I'm going to run it here in the UI. In the request, if you don't provide in the headers an API key, instead of getting 204, a successful status saying that the content was deleted, you will get a 401 saying, you know what, you're not authorized to do this call because it was also expecting an API key to be sent. So let's add that key back in and make sure that we get 204 resource not found status confirming that it was actually deleted. Okay, so we need to pass along an actual headers. And inside headers, we passing X API key So a key value pair. So X API key is equal to request rec res-free-v1. And let's print out the status. We can also just verify it. So expect response.status to be 204. Clear out the console and let's run it. Okay, 204 passed. And we can take a look at the report right here. That's it. It was deleted. Expected to be 204, no content, and it was deleted, so nothing comes back. We just deleted user number 2. Again, virtually deleted it because as soon as you reload the page, it loads back everything because this is a training API. But if it was an actual API hooked up to your client or just to your server and you send out the request to delete a user, it would have gone into database and deleted a user. All right. So yeah, that's it on the API testing using Playwright. This was alexusadays, and I will see you in the next video. Bye.
Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. So today we're in module 9 and we're going to talk about intercepting requests. Intercepting network requests in Playwright is a great way to test how the UI behaves under different API responses, especially when mock services aren't available or when the API is still in development. Let's explore how to observe, modify, and mock API requests during UI testing. Intercepting requests is useful when you want to simulate or mock backend responses without hitting real APIs, simulate expected API errors like user not found or validation failures, validate UI behavior when the API itself fails with server errors like 500 or 503, block unwanted requests, images, analytics, etc. We're going to take a look in more details in the network, Playwright Dev Docs network in a second. Use page.route in Playwright to intercept, modify, or mock network requests made by a web page during test execution. Playwright page route has several methods that can be used. Use route.continue to modify and send. Use route.fulfill to mock response. Use route.abort to block requests. When combined with assertions, request interception becomes one of the most effective ways to validate front-end and back-end integration in Playwright. And more details at Playwright Dev Docs API class route. All right, let's take a look at the docs and do some coding. All right, so we're at the Playwright docs and we're at the network. So this is a page that talks about the network requests, responses, how to mock APIs, network mocking, HTTP authentication, proxy, network events, and so on. So pretty useful just to get familiar with it, read through it to understand what Playwright has to offer. And then what we will be using specifically today is route. So route is a class that has a bunch of methods associated to it. So like abort, continue, fallback, fetch, fulfill, request. So we will use some of the methods available on route to show you how you can actually intercept a request that's happening on the page and then fulfill this request with a mock data and send something else, not what the backend is sending, but you can actually trigger some error scenarios, or you can show some special cases just by providing a response that UI expects for different scenarios and not the one that API was actually sending, right? Okay, so now let's take a look at the code. Here we will start in the test folder with a new file, and let's call this intercepting or intercept.spec.ts, and we will start by importing. So let's go to our API tests and just import test and expect from Playwright test. into the intercept file. And let's start with a describe block. So test.describe, test describe. And here we want to intercept requests with Playwright. So let's call it with Playwright. So this is going to be our describe block. Make sure there's no .only tag anywhere else. So we're going to use .only on this describe block and remove it from the previous one that we had in the API testing. Okay, and let's start with the first case. The first one will be mock a successful API response to get a user with a local JSON file. Okay, so test get user mock with local file async page. Now, do you remember that in the API we were actually using requests? We were not using the page because we were directly reaching out or using get method to an API endpoint. Now, in this case, we will use route and we will use it with the page. So route is part of the page. And we're going to reach out to get user to. And it's giving us some local file. So we're not going to do that like this. We're going to store like a mock. So let's create it in the test data. Let's create new file. User underscore to mocked. Something like that. JSON. And where the user to is coming from. So if you go to request response, here, if you click on single user, you will see there's actual API response that come into the UI, and the UI using is that to display this body in the UI. So this whole body. So we're just going to grab that response that UI is showing, and let's store it in user to mocked. And here, let's update something. So instead of Janet Weaver at recres.in, we're going to say test user, first name test, last name, let's call him intercept or intercepted. And for the text, I just want to say alexusadays. alexusadays. So for sure, I want to know that, you know, my request was updated and will be updated to this particular data that we're going to use when we will be fulfilling the route. Okay, so we have a file. Now we need to read from that file. So we're gonna say const mock data, and it's gonna be JSON.parse and fs.read file sync, read file sync, test data, user underscore to underscore mocked .json, and fs is giving us some problems, so we need to import it. So import everything, so asterisk as fs variable from fs, something like that. So we imported it. Now it's going to be used. So we're going to read the file. Going to parse it as a JSON. So first we're going to read it as a JSON string. We're going to parse JSON to JavaScript object then, and then we're going to store it in the mock data, right? So then we're doing route, page route. And I want to, I'm just going to put asterisk here. So that means I will intercept every request, any URL, but has to end with /API/users2. And because we're accessing a particular page, it will intercept that when the UI is getting user2, right, on that page. So async route. Now here, we want to route fulfill status 200 content type application JSON. So the body, we need to convert object back to a string suitable for the HTTP response, right? Okay, so we're gonna do that. So JSON stringify, and we need to stringify mock data. So the JavaScript object we're storing here in mock data, we actually sending back to a string. So this will be intercepted, and then instead of the body it has by default, so this body, it will fulfill the response with this body, we stored in the mock data, and with all this updated information. Okay. So some other things that, well, we did all that. Now we actually need to do some navigation there and some testing. And we want to also close our describe block. So here, still within the test, we want to do await page go to request recres.in. So on the home page, that's where we're going. And then at the home page, let's trigger this route using the UI. So we'll say await page page get by text. And what is the text there on that page? Single user. So I'll grab it by this text and click on it. Get by text, single user dot click. So what will happen? It will click the single user. And so first it will go to the page, then it will click the single user, and once the user is clicked, it will launch this request that we will be intercepting because it will try to reach API users too. And then instead of getting the response, the UI, instead of getting the response it would typically get normally, so this one, it will be fulfilled by Playwright. So with the data that we provided in the file. Let's take a run. Let's run it. So npx playwright test -UI. I want to run it using the UI so you can specifically see the response, how it's going to look. And this is intercept spec, and this is scribe block, and inside the scribe block, this is our test. So get user mock with local file. Let it run. So it reaches out. Locator click errors out. And there are two elements. So it's not a single, there are two elements on the page. So single user and single user not found. So let's grab it, locator, and see what suggests exact true. Okay, so Playwright suggests get by row link name single user exact true. So let's use this locator instead. So it's a unique one. So await here page dot get by role link, name single user, exact text equals true, and then click. All right, so updated the test. Well, let's run one more time. Intercept. Okay, here's the test case, and let's go. All right, so now it's clicking. And there's some other. This is, I don't know, this is something unrelated. There's some console errors, but this is something unrelated. Just some errors that are on the web page. So for us, what's important, so it clicked on this user and the response came through, and we can see what is the response now in the UI. Right? So after Playwright clicked single user and it intercepted the actual response that was coming back from the backend, and we fulfilled it with the data that we put in our mark file. So here's test user, first name test, and text is alexusadays, right? So everything that we had in the file came through, and we see it now in the UI. So this is one example. So we mocked a response and inserted it. Now let's do another case. Let's do some business logic here. So the user wasn't found. So simulate late error 404 error, user is not found. Okay, so test get user simulate 404 async page. Same thing. So what we want to do here is intercept the request and response with 404 error, and we're doing await page dot route user 23. So I'm just gonna have user 2, not 23. Same user. Let's see what happens if I use the same user, but instead of fulfilling it with the mock, I will fulfill it with a 404. So in 404, you know, the status code for 404 means that user is not found. And I will also send some body. The body will say user is not found. See how the UI actually handles it, if it's gonna parse it or not. And we can take the same route. We can say go to that link again, and then just click on the single user, and it will trigger a request being sent, right? So let's do that. And again, I'm gonna do npx playwright test. Let's run it. But now we're going to be running another case. So intercept, describe block. Here's within describe block, get user simulate 404 error, run it. And I'm kind of curious how it's going to look and what's going to happen if it receives 404. We don't really know, right? Because I don't know how the UI actually gonna handle this. So you see, we're clicking on it. This is the state before the click. This is state after the click. So when we clicked, and we can also look into the network. No network calls. Where are the network calls? Hold on, let's rerun this. Okay, yeah, here we are. Okay. So here we will find a route this was users and user 2. So here is this request, and we can see the response is coming back is 404, and the body is error user not found. And this is exactly what rendered to the single user, user 2. Now instead of receiving a 200 with our mock data, it's actually receiving the 404 that we put in as a response and showing the error message here. And we can see it in the network tab as well. User 2, 404 is being returned. All right. So if you have a bunch of error scenarios that you need to automate, but you don't actually have an API or user data to do all that, not the API, but yeah, user data, or maybe even not the API, but you know how the UI should respond to particular errors, you can put them all into the fulfill route and verify that the UI is actually rendering the errors properly and it shows what you expect it to show, right? So it's going to save you a lot of time for automating things that maybe you have some limited data, test data for those things, or it's kind of hard to trigger specific errors in the real test environment with the real backend, but it will be pretty easy with Intercept. Or I should say fulfill, but yeah, I call it Intercept because you actually intercept requests, right, in responses. Okay, so this will simulate 404 error user is not found. And for the last one, let's do some blocking of images, like style sheet, font request. So essentially, we're gonna have everything stripped off. We just want to have some text and links. If you're testing functionality, well, you have to go and click through links, or you see that the redirects are working, or you can click certain buttons. And page takes too long because there are a bunch of images, or tests take too long for the page to load. You can actually block all of those requests, and same way you can block any requests that are doing like analytics, data gathering, like anything that you provide for your resource type or for a specific link, you can block those, right? And if you block those, they're not going to show up on the page. So let's do that. In the third one, let's do block image requests to speed up page load, styles, and fonts, something like that. Okay, and then test. Let's call this block all images, styles, and fonts. Okay, so we want to intercept requests and block image styles and fonts. We're not going to do this. What we want to do, we want to grab all of the route. Everything is going to go through, and then route if const resource type is equal to request dot. So so for this, we don't need all of this code. Bunch of code. Okay, so we're gonna grab a resource type first as a variable, and then we'll say if we have an image, a style sheet, or a font, and it's included in the resource type. So within the route, for every link that goes through inside the request, if image and style sheet or font was in the resource type, it is included in the resource type. We're gonna say this. So we're gonna say console log. I'm gonna say that blocked resource, and let's provide a URL. We're gonna do route abort, route.abort. So we're not gonna allow this route to show up on the page. We're not going to allow this to be rendered in the UI. No, just abort it. Don't go through with it. Else, if there's no such resource type being sent and your route looks normal, like there's no image, no style sheet, no phone in the resource type, we're just going to allow route to continue. Route continue means just, go do your business as usual. This is our if else block. This is our test case, and close that. All right, and so before the test case ends, we want to actually go to the page, right? So await page go to, and here we go to the request recres.in. This is end of the describe block here. This is test case 3. Okay, let's run it. And you will see that anything that has resource type image, style sheet, or font for this particular case is not going to render any of those. And the page is going to look quite different. All right, so here's our intercept, describe block. Here's block all images, styles, and fonts, and let's run it. So by blocking all of this, you will significantly reduce the load page time, but also as a result, you see what you get, right? So if you verify if links are clickable, or you need to do some very functional tests, you can speed up loaded page by blocking resources, by blocking analytics, by whatever you need to block. You can put it in, provide it, and this is what you will see, right? Stripped out of a bunch of content type. And you see in the console it's saying we'll block in this CSS, again, more CSS, PNG, JPEG, resources. So every resource that was blocked, you can see it in the console showing up, telling what it blocked. And this is coming from this message. So before aborting the route, it just says what we are aborting. This is it. Again, take a look into the documentation, read a little bit more about route and what it can do, and read a little bit about Playwright Network and get familiar with it. But just by using this, mocking successful responses or mocking different errors, or maybe if you need to abort some of the things being loaded, you can generate a lot of scenarios that will test different things, even if you don't have your test data set up to test them, right? You can just provide it directly to the UI and see how the UI handles them. Okay, so this was alexusadays, and hopefully you find this video helpful, and I'll see you in the next one. Bye. Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. So we're in module 10, we're going to talk about page object model. Page object model, or POM, is a pattern for keeping test code organized and reusable. Instead of writing all interactions inside your tests, you create one class per page. When creating POM framework, try to balance two principles. Dry, don't repeat yourself, avoid duplicating code. And the second one is KISS, keep it simple, stupid. Favor simple, easy to understand solutions. Here are the main benefits of project using POM. It's easier to read, it keeps your test code clean and easy to understand. Reusability, you can reuse code for interacting with the same page across multiple tests. Maintainability, if something changes on the page, you only need to update it in one place. We're going to take a look into more details in the Playwright documentation just in a second. In Playwright and JavaScript series, I stored shared actions in a common action utils file. In this TypeScript series, we will follow a classic page object pattern. Shared methods live in a base page class, and every other page extends it. I'm publishing a Git repo that contains every file plus inline comments explaining why each piece is written in the way it is. We'll rebuild the same structure together in the video. starting from a fresh project for our POM example. The Playwright POM TS example project located here in the GitHub under alexusadays under Playwright-POM-TS. In that project, you will find 3 branches. One will be the branch number 1 with this basic page object model. The second branch will be modified with addition of fixtures to this project. And the third one will be base page object model plus fixtures plus GitHub actions. All right. So in this 3 modules, this one and 2 more upcoming, we're gonna render this project to completion, where it's gonna be a good to start framework to work with POM immediately, and also have it as part of CI/CD if you need to. All right, let's get into the code. Okay, so we're on the Playwright dev docs /POM. It's a page object models page, and it explains how to implement it. Talks about Playwright dev page, but for us it's going to be the base page where you have all the common operations. And then you can see that the page is being created with some methods in it. And then you can see this page is being imported to spec TS file and being used throughout the test. Right, so our structure is going to be more completed. We will have multiple pages plus the base page plus a page that manages all of them together. Okay, so here's the GitHub. It's alexusadays/playwright-pom-ts. And again, right now it has 2 branches, but it will have 2 more, and we will be in the lesson 00 baseline for this video. It has already everything done and completed. If you want, you can go ahead and download it, or just use that, or use the tag, click on the tag, and you can download the whole thing on your machine with everything within that wrap tab and completed in the final stage of it. Now we're gonna go and create one throughout the video right now, and we will use the internet.herocoop.com. We will go to the login page, and we will try to authenticate. We will have a login page. We will have a fail test case for login page. We will have a success test case on the next page where it says secure. So once it gets into the secure state. And we will also take a look at checkboxes page right here, where you can check different checkboxes, and we'll have a couple cases checking and unchecking them. All right. So for this, we will need to create new project. So we can't use the one that we had. So go ahead and just open a new folder or create a new folder, and in this project, start a new repository or a new Playwright project. You can say npm init playwright at latest to get started. And select TypeScript. That's going to be in test. We're going to add GitHub Actions workflow. Not now, but as we're going to move forward, we will. So for now, let's select false. Install Playwright browsers and everything. Yes, let's do that. And right now it's initializing the project, downloading browsers, getting started. So everything is downloaded. And here we have the package JSON, Playwright config. In the Playwright config, let's uncomment base URL. So the base URL we're going to be using for testing is going to be the herocoop.com. So this is going to be our base URL. So we're going to place it in the config, so application knows where we're going to go to start testing. And we have tests, and then there's an example file. We can delete that, and test examples folder also can delete that. All right, so from here, we want to create a folder called pages. And in this folder, let's start with the base page. So the base page will have all of the common actions. So new file, base page, and .ts. So base page, we're going to say import base page stores Playwright page instance. This class is protected, so only extended classes can access it. So we will have other pages that will be going into the base page and grabbing methods, they will be allowed to do that because they're extending base page, or other pages that will extend base page, and they can go and use what we will place in here. But if you're gonna go into the test file is not going to be able to reach that page. Test file will be able to reach only pages that we will create for specific pages, not the common one, not the base page. All right, so here we have import page locator and expect from Playwright test, and let's say export. So we're exporting abstract class base page. And what we want to create a constructor here. So base page is an abstract class, so it cannot be instantiated directly. It is designed to be extended by other classes, and we're gonna create a constructor here. So the constructor will be protected read-only page of type page, and it's gonna be empty. Okay, so this is our constructor. And let's start with our first. Method. We will do navigation. So navigation, going to navigate to a specific URL path. It's also a protected method, and it says go to URL. This is the name for our method here. It accepts path as a string data type, right? And then it will wait, and it will use the Playwright goto method to go to provided link, right? To go to the provided path. Okay, so we have a navigation. The other thing we need to consider is adding a utility method that will accept both Playwright locators or CSS or XPath selectors or even text. So we want to have some sort of utility that will give us capability to do both. And let's do that. So we'll call it utility, so we'll call it toLocator, so protected toLocator, and it's a selector that's either accepting string or locator of a type locator, and it will, if the string selector received, it will create a locator out of it. If it receives a locator, it will return it unchanged. So that's the idea behind this. Okay, so let's just type this one out, add it to your base page file, and now let's start creating and adding some more methods here, Okay, so let's start with the regular click. So we will say, let's start with the regular click. We'll say protected async base page click. So we want to highlight that this is coming from the base page click, and from the base page file. And again, we're just kind of wrapping up the Playwright click function, and we use toLocators, so it accepts either CSS, XPath, or Playwright built-in locators here, and then it just clicks on whatever element we're providing here. Okay. The next one is going to be protected async base page fill, and this will allow you to put some text value inside a locator that you provide. So essentially, if you want to type some text in, you're going to use base page fill. So it wraps up, again, like a Playwright built-in function or method to fill in text, right? One thing that I'm doing right now, because I want to exactly match what I already have in repository, so I'm just going to copy and paste parts of the code and go through them. But if that's too fast for you, just pause the video and then type things out, and then continue once you typed it out on your screen. Okay. And the last one that we're going to add here is, I'm going to format that. So protected async base page expect visible. So this is an assertion where we provide a locator and we expect this locator to be visible. So this is just some common methods that are going to be used across other pages. Now you can have more, you can add others. This is just for us as an example how you will get started with your base page, right? But whatever is being used by multiple pages, you can just store here and then use that in the pages that you're going to be creating. Okay, so next one, this page is done. Everything is good to go here. Next one, let's create a new page, and it's going to be login page. Login page.ts. So this base page will represent the login page of the herokuapp.com/login. So we're going to put some methods related to logging in and testing this page specifically. So first, we need to import the base page, the one that we created, and we want to report expect from the Playwright test. We're going to use that. And let's start with export class login page extends base page. So this page is using inline locators. Inline locators are defined directly in the methods, not as class properties. So you will see two different styles here. One will be with locators that are provided inline inside the methods. And the second one that we will create later, we will actually have locators be initialized with the class, so they're kind of sit outside for a different way to manage them, right? Okay, so export login class extends base page, and then let's go and navigate to the login URL. So it says go to URL. So go to URL is the base page method, and it will go to the path provided. So it will be our base URL, this one, plus /login. So essentially it's going to go to the login page here. I'm going to close out this so it doesn't error out. Close out the class. And let's add a login method here. So we'll say user, format this. So async user login, and it accepts username string and password string. And we're going to fill username and password fields using helper from the base page. So we're going to use base page fill function or method, this one right here, that will put in text into the selectors or locators that we provide. Now we will say for the username, we're going to get it by label. So inspect and inspect the username. So here's the username field, and there's a label username. So we're going to get it by label, and this is a Playwright locator. So we'll say base page fill, this dot page get by label username, and then we provide the value that we're going to put in there here after the comma. So username. We're using a Playwright selector for this particular field. The next field is the password field, and we're providing ID password for this locator, and we're using CSS selector here. So expected, here's the password and ID password. So we're going to use CSS selector to provide data inside to fill that field with the password value. And then the last one will be base page click, and here we provide XPath to interact with the element. But we're still using all of the wrapped up methods that are located within the base page. So base page click and the base page fill, everything is coming from here. Okay. The next one will be an assertion that login failed, because if you fail to log in, there will be a displayed message on the page saying that you failed to log in. So we'll call this function async assert failed username. Doesn't accept any parameters here or method, and within parentheses we have await this base page expect visible, and we provide the locator inline. So flash is the locator ID flash, and we want it to be visible. We're using base page expect to be visible method. And then we do another assertion. So this one is coming directly from the Playwright. So in the page itself that you create, if you want, you can still use Playwright built-in method without a wrapper, not coming from the base page. So on line 22, you can see we're doing await expect this page locator flash to contain text. So we don't have it anywhere in our base page. We're just using it directly from the Playwright expect from here, right? To contain your username is invalid. All right, so login page is done. This is our method that we're going to have for the login page. And next one, if you do get to sign in and you provide a valid password and username, you will get into the secure page. So let's create that. So new file, secure page.ts. And here we're going to import base page, and we're going to import expect from the Playwright. And we're going to say export. So this is class secure page that extends base page, right? And then inside, for this particular class, we're going to do assert success. So once you log in, you can see a message that you logged into the secure area. So we're going to have a method for this. It is using an inline locator. Again, we're not having it at the top of the page. It's still within the method. We store it in a banner variable using this page locator. ID flash. We use base page method to assert that it is visible, and then we use Playwright API to assert that it contains a certain text. So it contains you logged into a secure area. Okay. And the next thing that we're going to do is a logout function or a method. So we're going to say logout, and we will say await this page get by role link. Again, we're using built-in Playwright here without any wrapper. Then we click on the logout link, and then we will verify. Well, we wait for the URL to change to login URL instead of secure. Okay. So this is our secure page. It's also done. And next one is checkboxes. New file, checkboxes, page.cs. Now here we're going to import base page, and we're going to import a locator from Playwright, and we're going to import expect. So this page is using reusable locators. They're not going to be in line, and it will require a constructor. So we start as we usually start. We will say export class checkboxes page, and it extends base page. And then we need to declare reusable locators for the checkboxes, or just declare usable locators. So whatever we're going to be using on this page. And we will be using first box and the second box and a form. So 3 locators. If we go to the checkboxes link, so here we are declaring this locator for the first checkbox. We declared the one for the second, and then for the whole form. Okay, so let's get back. So we have 3 locators declared. Now we need to actually initialize them. So first you want to create a constructor that is accepting page, and then you want to use the super constructor coming from the base page, so to make this page available. And then we initialize reusable locators. So we're going to have this first box with checkbox 1, and then second box for checkbox 2. And for the locators, we actually are going to use page.locator, form checkbox input nth0. And then for the second one, we're going to use page.locator, form checkbox input nth1. And also we're going to use this form page locator form checkbox. Okay, so 3 locators are initialized right now. And now let's navigate, add a method to navigate. Let's close the class first so it doesn't error out. Okay, so we're going to add a first method to navigate to the checkboxes. Navigate to page and verify form is visible. So we go to the checkboxes. This page go to URL checkboxes, and we use base page expect visible, and we make sure that this form right here, this locator, is visible. Again, we declared it now at the top, then we initialized it in the constructor. Now we can use them throughout the whole page, and we don't have to provide it in line, right? We just need to say in the constructor, this is the one that we're using. So this form is coming from here, and that's what we're asserting to be visible. All right, so next one is going to be, I'm going to create a specific method to check the first checkbox. So it will use Playwright method checked to check the checkbox. So it uses await this dot first checkbox, again this locator right here, and we're checking it. The next one that we add is the uncheck. So we go and uncheck the first box to make sure the check is not placed. And let's do the same thing for the second box. So we're gonna get two more methods going in. One will be to check the second box, and one will be to uncheck the second box. Okay. And the last method that we're going to use is we will have an assertion. So we want to validate if we actually have an element in checked or unchecked state. So let's call it assert checkbox state. It accepts the Boolean, so either true or false value. Two parameters, one is the first is checked and the other is second is checked. So we expect this first box to be checked either to be true, checked true or false, so whatever we pass into this method. And the same thing for the second one, we expect it to be either true or false. So based on what we provide here, the parameters, it will verify if it's true, if it's actually checked or unchecked. Okay. So yeah, this is our checkbox pages, and this one is ready. So now we have base page, we have login, secure, and checkboxes. So we have 3 pages that extend base page. The last thing that we want to do is to create a manager, so manage page, that will unite all 4 of those, or 3 of those, for the ease of access or ease of use. I'm going to say manage page.ts, and inside the manage page, so we import the page from the Playwright. We import login page, we import secure page, and we import checkboxes page. And now we need to initialize them. So first, let's create the class. So say export default class manage page, and we need to add a constructor where the page read-only page sits. And now let's do cache undefined until the first access. So all of the pages are cached in until the first access. And now we're going to have a lazy getter that will create the page object on first use and then reuse it. So instead of initializing them, all of them, and creating them, all of them, whenever you run the page, you only do that when the page is being accessed, and then you reuse it. So lazy getter, get login page of a login page type. If this dot login, if it doesn't exist, if it's false, then we will create new login page. Otherwise, just return this login from here, right? If it's already created. So this is the lazy getter, and this is the way to kind of save resources, so you don't have to initialize all the time, only when needed. And for the other pages, we're gonna use same lazy getter, but like a shorter version of the same code. So we'll say same lazy getter code, but in one line. get secure page of the type secure page, and it returns the secure page, or if not, then creates new secure page. And the same thing for the checkboxes. And this is our manage page. So any page that you create, you add to the manage page, and then when you export manage page, any tests that you're going to run will use your manage page to reach out to all of the pages that you created. And let me demonstrate it and actually get to the test now. So let's create the new test. So new file, and let's create a login.spec.ts. So this is our first test. Everything in POM. And we need to import, so let's import test and expect from the Playwright. And let's import manage page from pages manage page. So this page that manages all other pages we're importing. Let's start with test describe block, and let's do login flow. Login flow, we're gonna delete all of that. And let's call manage page MP, so it's shorter. So we're creating MP that uses the manage page that we imported. This variable MP will be the way how we access our other pages that we create in methods. So we need to create variable MP that stores the manage page. And then before each test, create a new manage page, and that's the new page objects. So before each, we'll have MP created, assigned with the new manage page created. Okay. So every time we run a new test, we have a new page object. All right, test, and the first test is going to be login with valid credentials. So test, and you will see how easy it is to read now. So test should log in with valid credentials, right? And it awaits for mp.login page. So through manage page, we access the login page, and then we're doing open login page method here. So it will go into the login page and run open login page, and it will go to the /login URL. So then we'll enter valid credentials and submit. So we provide user login. Tom Smith is the username, and super secret password is the password. And again, it is accessing login page and user login method here. So in the login page, here's the user login method that accepts username and password, right? Then we verify in the secure page, because once we logged in into the secure page, we will verify assert success. Okay, so let's run it. Let's do npx playwright test --UI. Let's run it and see how it works. So here's our flow. We go to the app.com login. Then in the username, we enter Tom Smith. Then in the password field, we enter password. We click login button. We get to the secure area, and then we verify you logged into the secure area. So all of the steps are here. Going to login page, entering the Tom Smith, entering the password, clicking on the button, expecting the element to be visible and contain specific text. This is already on the secure page. So you see, we had a lot of preparation for this, but now tests are very easy to write. And essentially, we're just reaching out to the method that we placed inside the pages, right? Method to log in, method to open login page, to enter user credentials, to assert success on the secure page. And let's add a test case where you actually fail. So test should show error for invalid credentials. So we use the same open login page to navigate to the page. We use the same user login method, but we say bad user, bad password. So we enter invalid credentials, and it will click the login button within this method for the user login, right here. And then as a result, it will get a failed message. So we say assert failed username should run here in this test, and assert failed username again is part of the login page. And this is this method, and it will go and grab the locator for the message being displayed, and then it will verify that the username was invalid message is there. So let's run it. So here it was added into the Playwright. Let's run. Here navigates to login, enters bad user, enters bad password, clicks on the button. So before action, after action, clicks, and then you see your username is invalid appeared here on the top, and we assert that it's actually there and the message is there. Yep, and that's it. And we're done, and the test completes. Okay. So when you have big projects and you want everything organized, and there will be a lot of different things on each page that you need to go through and click and do different actions, you can place those actions within the page files and then keep on using them in your tests. And if something changes on the page, you don't have to go through all of your tests, changing those tests. You just go to the page file and change something that was updated on the page in the page file. All right. And the last, let's create a new test, new file. The last one will be checkboxes. .spec. And checkboxes, the main difference for the checkboxes here is that instead of inline locators, it uses reusable locators that we declare at the top here of the class, right? Inside the constructor, we initialize them, and right after the class create, we declare them. But again, same methods coming through, we're going to be using those. Nothing really that different here aside from the style, how we deal with the locators on that particular page. If you have a lot of locators, like 15, 20, maybe it's a good idea to have like its own file, import it, or have it within the page. If you have a few, then just you can use them inline just like this. Either way is fine. It's really about how you're gonna structure your page object model. Okay, so for the checkboxes, let's import test from the Playwright test, and let's import manage page from pages manage page, right? Because through manage page we access all other pages. So we're gonna start with a describe block that says checkboxes page, and we're gonna declare a variable to hold the manage page instance. So let mp manage page, and then we need to, before each test, we need to create a fresh instance of manage page to ensure each test starts with a clean state. So test.before each page mp is equal, so this variable is being initialized, assigned new manage page created, right? First test is going to be, we will check the first box and then check the second. So the flow here is pretty easy. So we go to the checkboxes page, and we use open checkboxes page method to navigate there. Then we click the first check. We check the first checkbox, making sure that it is actually checked, and then we uncheck the second one, and then we will assert that the first one is checked, it is true, and the second one is not checked, and it is false. So let's give it a run. Go into the checkboxes here. Here is our test. Let's run it. Navigate into the checkboxes. Here we are. We expect to be visible form of the checkboxes. Let's confirm. Then we want to check the first, so here, before, after. So action happened, it been checked. Then we want to uncheck the second one. It is unchecked. And then we want to assert that the first one is actually checked and the second one is actually unchecked. And that's it. Test passes. And now let's create another one where we uncheck both of the checkboxes, right? So test, uncheck both checkboxes, await MP checkbox page, open checkboxes page, MP checkboxes, uncheck first checkbox, and then uncheck second checkbox, and then assert both the first one and the second are false. So both are unchecked. Take a look in the run here. Here's the test case, run it. Go to the checkboxes. We assert the form is visible. We uncheck the first one. If it's already unchecked, just make sure it's unchecked. It doesn't click it, it just stays unchecked. Unchecks the second one, and then it verifies. Expected to be checked. Maybe not a good name. Expected to be checked. Maybe something like, yeah. We could add some like text wrapper. So here saying it's not expected to be checked, but it is expected to be in a certain state. So we could add some text explaining ourselves a little bit better. But I think from the name of the method itself, assert checkboxes state, it's quite clear. So it's either be its first check can be true or false. So the state could be true or false. It could be either checked or unchecked. So I think that's okay. Even though when you read through it, it's just, does it actually verify that it needs to be checked? No, it's not. It's looking at either checked or unchecked. All right, I think this is it. So again, all this code is actually, so you can type it out for yourself. If you just want to kind of follow along, typing things out, and you should practice, typing it out. But also all of this code now, it's available in the GitHub, so playwright-pom-ts under alexusadays, and use the branch, use branch less than 00 baseline. So this is just the pure page object model. There will be no fixtures here. No GitHub action. So just as you see it, what we created in the video is available here. So you can download it, and you can use this as your boilerplate code to essentially get started with a page object model with the Playwright using TypeScript. It has some reads here on some explanation on the protected class and how it can be used only by the pages that extend base page, but you can't really directly access base fill through a test file. Talks about encapsulation a little bit and why we use protected. And yeah, that was alexusadays. Hopefully this video is helpful. Thank you for watching, and I'll see you in the next one. Bye. Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. We're in module 11 today, and today we're going to talk about Playwright Fixtures. In Playwright, Fixtures set up the test environment automatically. Instead of hand coding before each, after each, you define a fixture. Playwright test creates it, injects it into the test, and tears it down when the test ends. Main benefits of using fixtures. Reusability. One fixture can serve every spec file in the project. Maintainability. Change the setup in one place, every dependent test benefits. On demand. A fixture runs only for tests that request it. No wasted time. Quick implementation notes. When you will be importing test from the Playwright into your fixture, import it as base, because you will have to extend it and you have to have it named something else, not test. So typically the way to go around it when you import it, name it as base, and then assign base back to the test. I will show you on the code how that looks. Also, define a fixture map type. So anything that you have to have in your fixture, give it a type for strong typing. For example, here, logged in page is the type of a page. And then code above await use runs before the test, and code below runs after. This is also something I will show you once we get to the code. Okay, so we're at playwright.dev /docs/test fixtures, and we can see here fixtures introduction. So Playwright test is based on the concept of test fixtures. Test fixtures are used to establish the environment for each test, giving the test everything it needs and nothing else. So we've already used fixtures. In Playwright, when you use page, you use a built-in fixture, because page gives you browser, gives you context. There's some additional settings. If you want to set up it from scratch, you have to define all those things. Page is a built-in fixture that Playwright has that does it for you. But we also might want to use our own fixtures or extend the existing one, and let's see how it works. We're going to move into a new updated code that will have a fixture. But if you want to check out the old one where you have only page object model without a fixture, just go to my GitHub repo. So alexusadays playwright-pom-ts, and you will see multiple branches here. So branch that says baseline, this is the branch that will have page object model only. Branch that says lesson 01 fixtures will have the fixture that we added today. The code that we're updating today is going to be here once we're done. Okay, so here we are in our code with the page object model, and you can see in the pages we have a manage page that has all of the pages here, but then when we go into the test, we need to use before the each test, so we actually initialize the manage page, right? Now, we also have login credentials right here in the test, which is not ideal. So we'll start with two things. We will start with adding a fixture that will hold both this manage page and the user login. So first, let's create folder and call it fixtures. That's going to be one folder, and also let's create a new folder and call it test data. Now in test data folder, let's create new file and let's call it valid user.json. And inside the file, we will need to provide the details about the user we would like to use. So we'll say username. To log in, the user name is Tom Smith, and the password is super secret password. So here in the file, when we do the login test, we will have it imported from valid user. That will be imported into the fixture first. Okay, there's a little typo. Remove the comma here. Okay, so valid user now looks good. Now in the fixtures, let's create a file and call it pom fixture.ts. And inside here, we're going to add a comment. So we're creating a Playwright fixture that initializes a page object manager, POM manager, for each test. This allows us to access various page objects like login page, secure page, etc. through the manager. The fixture also provides a valid user object for authentication tests. So that's what we're going to do here. So first thing, we have to import test as base from the Playwright. So if in our test file we import test from the Playwright and we don't rename it, we keep it as test. So in order for us to use the same test here, when we import it from the fixture, we need to first assign test to base and then assign base back to test. And I will show you how it looks when we're done with this file. All right, so now we say import let's call it POM manager from manage page, from pages manage page, and also import valid user from test data valid user, or let's call it just user. Import user from valid data from test data valid user JSON. Okay, so here we need to first we need to do the type. So we create a type my fixtures, and inside that type we'll have PM. The PM is actually a POM manager, and we will have a type of a valid user that accepts username, that is a string, a password, that is a string. Okay, now with this being complete, we want to export the fixture. So we want to say export const test. And now we assigning the base and we extend my fixtures. So this type, we're extending the base back to the test. And then here we can still import the test now, but that test we will be importing from our fixture. And you will see how it works once we're done with the code. Okay, so here we want to reuse Playwright page object, await, use new POM manager that gets the page. All right. So here, so what's going on here? We create the resource. So create the POM manager with the page object and hand it to the test right here. We also want to provide valid user object for test that needs it, or let's make plain value fixture available to all tests. So plain value fixture available to all tests. So we want to say valid user is equal to user here. And let's close it. Okay, so we're exporting now this new test from the fixture. This test is actually the base test coming from the Playwright test being extended by the page object manager value, the page object manager object, and also has a valid user available that is coming from test data valid user.json file. One thing also you can do here, you can expect from the Playwright also from this file. So now both the expect and the test will be coming from the fixture. And that's going to change our files a little bit. So let's take a look at our login. So what we're doing now, we don't have to have the manage page over here. We want to remove it, and the before each block we want to remove it, and we can just say well, first we actually need to import, so we don't import from the manage page, we don't import from the Playwright test. Now everything is coming from the fixture. So we're going to say import test and expect from fixtures pom.fixture. Okay. Okay. Now we want to actually add, so where are we going to use it? Where are we going to use it? So inside here, async, want to pass it along. We want to say PM. So that's our page manager and valid user. Okay, so both of those values are now coming from the fixture. And now we want to do, instead of MP, because that's what we declared before, right? We declared manage page as MP. Now we named it a different PM, so we will say await PM, open login page, open login page. Valid credentials. So we can say await PM, user login, and then we want to pass along valid username and valid password. Where's valid username and valid password coming from? So here we imported valid user, right? So the user is the valid user coming from the valid user.json. And we go back to valid user. We see this username and this password. So those variables is being added here in the test. Valid user.username. So essentially, this valid user.username. So the value inside gets into the test. And then same with the password. And the last step here, assert success. So we're also going to say pm dot secure page assert success. So now instead of using the manage page and creating before each from the manage page and reaching out to it every time before the test runs, everything is done in the fixture right here. Here's the POM manager imported from the manage page, then assigned to the PM variable. And now the POM manager with the page is available to all of the tests, as well as the valid user that is coming from the JSON file from the test data folder. Okay, so now we're looking at our login spec, and the last thing we want to update here, we want to do the same thing. So we're passing along the PM from the fixture and updating all the MPs that we used to have to the PM. And now our code looks a lot less complicated, a lot easier to read. Cannot find module. Let's see if I'm missing something. Fixtures, pom.fixture. Does not exist. Do I have a typo somewhere? So we're at the root. Let's try to type it out. Dot fixtures pom fixture. Okay, so I guess there was something. I'm not sure what's different here. Oh, okay. So there's a typo. So it's fixture. Let's update the name of the file. So from fixture to fixture. Yeah, like typos is one of the most common things how you get bugs. So I think we should be good now, correct? Do you see it? Fixture, yes. We are all set. Why are you trying to add the comment here? So here's our test. So let me add some information, some comments here. So what are we doing? So we're using Playwright Fixture to access the page object manager, POM manager. This allows us to write cleaner and more maintainable tests by encapsulating page interactions within page objects. There is no need for before each for PM. Instead, we directly use the PM fixture in each test to access the necessary page objects. The valid user fixture provides a valid user object for authenticating tests. One more thing that I wanted to do here, so we added expect. So we want to do some assertion here. Let's see how we can do some assertion. So we're going to say await, expect, and say PM dot can we do PM dot login page dot locator, and let's pass in the flash locator to see that we see a certain message when we log in. Now here's the problem: we don't have this method in the login page. So we go back to login page. The locator, we don't have a method locator on the login page. What about base page? We don't also have a locator. We have base page click, we have base page fill. But what if I want to reach a locator directly without making the page public? Still, I want to have a protected page, but I want to be able to grab a locator. So let's add a public locator method that will allow us to reach for a locator directly from the test file for one-off assertions. So let's say public locator, and it's going to be either selector of type string or type locator. That will be a locator. The type of locator is locator, and it will return simple this to locator with the selector value provided. So what we're doing here, and this is going to be a new code. Let's format. So if you need a quick selector in .spec test file, doesn't matter which page you're on, and you want to reach out for a certain element, we can have this public locator method. It uses the utility toLocator inside the locator method, and it allows you to pass along any locator you want to use directly in the spec file on any page, right? Because it's located in the base page. We'll go back to the login. So here we have to have it inside the test. So let's go inside the test. Await, expect, PM dot login page dot locator flash to be visible. So it's a one-off assertion that we're doing after attempting the invalid login, that we're doing directly in the test file, not through the method that we defined in the page. Okay. And I'm going to have a comment here. So using the expect assertion directly from the fixture, this is a quick way to check visibility of an element without need to create a dedicated getter in specific page. We added a locator method in base page to allow quick access to elements. All right, now let's go and update the checkboxes. So same thing with the checkboxes. We don't need the before each now, and we can just get the fixture going here. So let's delete the MP manage page. Let's delete the imports that we no longer need. So we're gonna do import test and expect from fixtures POM fixture. And I like how Copilot is updating the code for me, but I don't want to do that so fast. So I want to walk through it. So let me just first let's rename the test. I'm gonna say here, so mix page object manager helpers and row page actions, and we imported the PM and we imported page. So here I will do a couple things. So PM checkboxes page, open checkbox page, yes, and then get the first checkbox, yes. Now I'm gonna delete the assertions that I have, and I'm gonna do again expect here. I'm gonna use the page. So we'll say await expect page to have screenshot, and then let's name it checkboxes first checked, right? Or checkboxes after check. After check. So this is one. And then we're gonna say await expect PM dot checkboxes page locator form checkboxes to be visible. All right. So here, what we're doing here. So again, we are using fixtures, right, instead of the object manage page. So the structured page here is coming. Okay, so now we have a page. Where is this page coming from? So this page again is coming from Playwright's built-in fixture. We're not using this page, the protected page, but actually this one is coming from the Playwright. So you can use the page that's coming from the Playwright for safe one-off utilities like screenshots, tracing, network intercept. Doesn't open new tab or context, right? And you want to keep the business interactions like check, click, fill, assert inside the POM. But if you need to use it one-off, same with the expect and the allocator, same with the page, you can have it in your tests as well. All right, and now let's update the last test file. So again, instead of MP, we use PM, checkboxes, open checkbox, uncheck first checkbox, uncheck second checkbox, and then assert checkbox status false and false. Okay, good. And we also need to pass along here our fixture PM, part of the test. We are all set. Now let's give it a run. Let's do npx playwright test dash UI. Something failed in the test number 1. Expect form checkboxes to be visible. No, not that one. Actually failed. Oh, yeah, sure. So we actually, I forgot. So we added a snapshot to have screenshot. So every time, if you run to have a screenshot, and then there's no screenshot, it will create one. So it just created a screenshot here that we'll test against. So the next rerun should pass. Run one more time. All right, so it looks good. So here is our checkboxes test. So we go to the page, we do the checking of both the boxes, and here we expect the form that it is visible. Then we do the check of the first checkbox. Then we verify the screenshot is there for this page. Then we expect the form to be visible. And you can see after hooks for the fixtures are also here. And here are the before hooks. So we don't see any of this. This is handled by the Playwright, right? So with everything else, this is what we did in our test case. All right, now let's go and look at the login, the flow. We go to the page. We fill out the Tom Smith. So the value, you can see it's been filled, and then password has been filled. We click the login button, and we verify that this message is visible and that it contains certain text. Okay. And then we have another test case that is. So here, we actually missed. So there was another case with the checkboxes where we went to the page, unchecked both of them, and then verified that they're unchecked. So to be checked is false, right? So back to the login flow. The second test case, we tried bad username, bad password, clicked login, see the username is invalid, it's visible, and asserted that it contains the text we wanted. So now here we updated our page object model and added a fixture in, and this fixture now imports the POM manager that from the manage page, and now we don't have to use it before every test to get the POM manager going to be able to reach to all of the pages. So saves us some time. And we also have here a valid user that we're using as part of this fixture, making it available in our tests for the login as well. All right. The tests look a lot shorter. There are a lot of comments here, but this is mostly for explanation. If you get rid of the comments, we got to a lot less lines and a lot clearer code within the tests. All right, this was alexusadays. Hopefully this was helpful, and I'll see you in the next video. Bye. Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. Today we're in module 12, and we're going to talk about CI/CD and GitHub Actions. CI/CD stands for Continuous Integration and Continuous Delivery, or Continuous Deployment. The software development practice that automates the process of building, testing, and deploying code changes. It aims to make software releases more frequent, reliable, and efficient. CI/CD make it easy to run Playwright regressions on any code update. GitHub Actions is a CI/CD platform that automates software development workflows directly within GitHub. GitHub Actions benefit you will have easy setup, can add it with Playwright installation or add the workflow yourself. Regression safety net, every push runs the whole suite, catching breakages early. Crystal clear diagnostics, HTML report, video and trace artifacts attached to each run. Visibility, live green, red badge in README, plus status checks in every PR. We're going to take a look in the documentation just in a second and read a little bit more about CI/CD and Playwright. So what we will be adding and updating in our fixtures repo. So we'll update the whole fixtures into a new branch where we'll actually use GitHub Actions. And we will have to add .env, a file that will store the secrets for the test user, for the test password, for the base URL. In the real testing, when you will have credentials in your system, you're not going to store them in a public file, and you're not going to push them in the repository where everyone can see them. Your passwords and everything else should be separated and stored separately in the environment so nobody else can have access to them. If they don't have a permission, they shouldn't be able to access your credentials. Then we will update .gitignore file, and we will add .env inside .gitignore to make sure we don't actually push real credentials into the Git. We'll also update Playwright config glue, and we will import .env into the Playwright config, so we can also read base URL from the environment variables. We'll have to do the credential fixture update, so we will need to create valid user.ts instead of JSON file, because valid user now will also be using the actual secrets. And we will have to create a GitHub secrets itself inside GitHub, so we're not going to be using the passwords that we stored in the local environment. We will be storing separate passwords behind the scenes where no one can get to it inside the GitHub itself. We'll have to go to the settings, go to the actions, and store the secrets there. We will have to add workflow file, which is the config for our GitHub actions. It is playwright.yaml, and this file will be stored in .github/workflows. We will add a badge inside README, so we'll have green and red status for the test runs, visible to everyone, and we will store artifacts and download them, and we'll be able to take a look at the artifacts. So we will also explore the difference between the two branches. So the one that we have right now at the current state with just the page object model and the fixtures added, and the new one where we have actual GitHub actions. All right, so let's get into it. Here we are in the Playwright docs, and it talks about setting up the CI. And inside, you see a special section on setting up GitHub actions, and it's actually talking about creating the YAML file for the configuration for your actions. So to see your pipeline running and the GitHub actions running, you actually need to add .github/workflows/playwright.yaml file. And this is the config, the example config that we have. Now I will show you the configuration that I have with all the comments in it. This is the changes between the current repository, so lesson 1 fixtures, and how it is different from the one that we will be completing. So this is already finished branch on the repository, CI GitHub actions. So over here you can see that we added this playwright.yaml file with all the config details. Then inside gitignore we added .env file. We also updated user that we were importing into the fixture from the JSON file to the TypeScript file, and we imported valid user instead of just the user file. And then I created a checklist, something you can go and see each step what needs to be done to get this repository going. We have .env installed, so to be able to store the variables or secrets. We added the .env, imported it into Playwright config, and now instead of base URL being a direct Heroku app URL, we actually get it from the env file, from the process. We also updated a README, and with this line, there will be a GitHub Actions report, so saying if you run passed or failed. The documentation, the README was updated with all the branches and the tags. There is a valid user TS file now, so instead of JSON, we get the valid user from the TypeScript, and inside the valid user, it's actually grabbing the values for the test user and for the password from the actual secrets from the .env file itself. Now, here we have max diff pixels ratio added. So I had to add a little pixel ratio when you take a screenshot, because the GitHub Actions is running in Ubuntu, and we were doing it on Windows. So there is a difference between pixels on Windows and in Ubuntu that you want to account for. So this is kind of like a byproduct of having multiple different environments and systems. So we want to make sure that, if we're still taking a screenshot, it passes regardless of the system you're running it on. There's a TXT explaining why I added a file and explaining why there's a mismatch and how to avoid it. And we added one fail test case to see the actual failure. How we should approach this? Well, one of the things that you could do, you can create your own GitHub account. So go ahead to github.com and create a new user. Once you do that, inside that user, you're not going to have any repos. So go and find alexusadays, and you'll hit users. There's alexusadays, not one, not the info, just alexusadays. And here you have Playwright POM TS. This is the repository that you need. Click on that. Then you can do fork. So you can create a new fork. It will copy this repository that I have into your GitHub. In this repository, we have 4 branches. Main is with the latest stuff, which will match the latest branch here. And this is CI GitHub Actions. So there's actually a repository with all things that are needed to be done, already done. Then we have a fixtures one. This is your current. And then by the end of the lesson, we will be up to date with the GitHub Actions. And then you have the baseline without the fixtures, just the page object model. Now here also, if you don't want to do any installation of a GitHub account, creation, like forking, anything like that, you just want to get to the repository, the files and everything, you can go to tags, and inside tags, just download the latest one with GitHub Action onto your machine, right? But what we will be doing, we will be forking this one into your new repository, and you want to go fork, a drop down, create a new fork, and this again will happen from your account. Create new fork. We don't want to copy the main branch only, we want to copy all of the branches. So let's unclick this and then fork it. Now, inside of your GitHub account, you will have the repository with all the branches, with all the tags cloned. So this is the latest one, and we have here everything. So we have YAML file, the config here. We have test data file updated to the TypeScript instead of JSON. Here is our CI tag. There is updated README with everything you need. We want to get manually there. If you want to have everything ready to go, this is ready to go as an example. But let's see how we can actually go and update the existing branch that has only fixtures into GitHub Actions branch. So you can actually do pull request and have GitHub Actions doing testing automatically. So in your account, we'll go to the actions, and I want to enable the actions here. It will use the config, but for us, since we did the fork, let's actually download this repository on the local machine. To get this on your local machine, go to the code here, click it, and choose one of the methods how you want to clone your repository. HTTPS, SSH, or GitHub CLI. So let's do GitHub CLI, for example. So I would like to learn more about GitHub CLI. It asks me if I want to download it. Sure, let's download it for Windows and install. Once the installation is complete, in your search, type in terminal and it will open up terminal. And now if you do GH here, you should see GitHub CLI available. All right, with that being said, now we can just copy this command for GitHub CLI, go to our terminal and paste it. All right, so to get started with GitHub CLI, please run gauth login, alternative populate gh token environment variable with GitHub API authentication token. All right, let's do gauth login. We're going to use GitHub, github.com, protocol, HTTPS, authenticate using GitHub credentials. Let's do that. Login with a web browser. First copy your one-time code. Okay. Copying that. Press enter to open GitHub login device in your browser. Here at open new window, I need to provide my credentials here. So username, password provided, sign in. I would like to save, sure, continue, display the code. So here we have DAD 9578C. Continue. All right, so after we authorized everything, the CLI should be all set. Now I can go ahead and copy this command, go back to the terminal, and just paste it. And it will install wherever path you have here. If you want to navigate to a particular location where you want this repository to be stored, go ahead and do that, or just clone it into the default location that you'll have it here. And then we copy the command, we go back to the terminal and just paste it. Now it should start cloning. All right, perfect. So now you will have in the location provided here, you'll have the repository clone. So let's open it up. And here I have Playwright POM TS that was forked, and now it's available on my local machine. So you want to open this in Visual Studio Code. Just open folder where your forked repository was downloaded into. Click open, and here we are. Yes, we trust the authors. Everything here is latest. Let's bring up by clicking here, a little warning at the bottom. Let's click on it and bring the terminal, the console, and the terminal. Let's do git branch. Okay, we are in main branch and do git branch r remote. So we want to check out into git lesson 01 fixtures. Git checkout lesson 01 fixtures. All right, now we have a repository and a branch that doesn't have any changes. Here, everything that was on fixtures. And git branch -r, and now we can see the main one. We can see the baseline, the fixtures. We're on fixtures. Git status. Let's check out fixtures into something new, like your own repository that you can update, and you will have GitHub Actions for it. So let's do git checkout -b, and let's call this your _GitHub actions. GitHub actions. Whatever you want to call this repository, let's do that. Okay, so again, do git status. We're on branch your GitHub actions. Now from here we can start getting in, manually getting into the point where it actually will have the GitHub actions in the GitHub that you have here. Like essentially, we're going to create everything that we already have in the lesson 02 CI GitHub action, but we want to do it ourselves to see what was added. And if you need assistance with that, aside from the video, inside the README, in the main branch, here's a checklist that you can go through to understand what to do. So the first thing we need to do is install .env. So let's do that. And I'm just going to follow along the checklist. Have them side by side. Clear out the console here and npm I dash for capital D .env. Okay. So when I issue this command, I can look into package JSON and see that .env was added. It is added in package JSON in dev dependencies. The next step is to create .env file. So we can do it through the touch space .env command, or we can just go into our Explorer, right click, new file, and create .env. Inside that .env, we're gonna have our test user equals to Tom Smith, test underscore pass is equal to super secret password, and the base URL is equal to not the example.com, but actually the base URL will be the internetherokuapp.com login. That's what we want. So all of those variables are going to be only local. They're not going to go into the GitHub. This is something our local runs will use. All right, we also want inside git ignore, we want to add .env file. So whenever we're going to push the update back inside the GitHub, everything that's in .env is not going to go out. It's going to be still on your system, it's still going to be hidden. So we're not doing any public passwords or users. Nothing's going to be available in the GitHub itself. The next step, we want to, after we add it to the git ignore, we want to convert our credentials. So in the test data, we have valid user JSON. So we can rename it and say TS instead. So it's going to be a TypeScript. And first of all, we want to import the .env, the one that we using, and we want to update a couple things. So we want to have this values exported. I'm going to export it as a valid user, as a variable valid user, and inside we will have a username that is taking its value from process.env.testUser, essentially from this file right here. Same for the password, also taking it from the .env file, this password. So everything that was just stored in JSON becomes obscured and kind of a secret, and it's grabbing it from the environment variable. If no environment variable provided, it can get it, then it will use a placeholder string. Okay, that's what it does. 2 question marks placeholder, that's going to be something if this doesn't go through. Okay, .env created. The next one, we need to update our fixture TS. Let's go to the fixtures, POM fixture TS. And now we want to import valid user because this is what we now exporting. So we're just gonna say valid, copy this. So valid user, and instead of JSON, it's gonna be TS, right? Can you see it? Let's make sure you can see it. Valid user. Okay, test data, valid user. Good. Now, here we don't need to assign user to a valid user. We just can update this as a valid user is equal to this valid user, or just have it as a one-liner like that. Okay, everything else stays the same. Nothing gets changed in here. We're good. And we going into step 6. So we want also to load the variables for the base URL inside Playwright config. So we go into the Playwright config. We will still need to import the module that we installed for the environment. So import .env config right here. And so same way how we did it in the test data. And for the base URL now, we don't need to use the internetheroquapp.com. Again, we want to obscure it. We will be using process.env base URL right here. Okay, good. Now we actually need to add a YAML config that GitHub will know and understand. Okay, you have this GitHub Actions enabled. There's a bunch of things here. Now, there are no comments. So if you want to have comments, this is something that is inside the main branch. Let's get to the main branch to see the comments inside the config. Let's go to the code. Let's get into GitHub workflows, and let's get into this file. So this one will explain everything, like what is happening on each stage of this file. And I'm going to first let's create a new folder. So I'll call it .github. And then inside that folder, we need to create another folder called workflows. And then inside workflows, you need to create a file called playwright.yaml. Okay. Now in here, we're just going to paste this YAML config, and it has a lot of comments. So you can either use this one, or you can use one from the main branch. The reason why I grabbed from the main branch, so every line here is explained. This is label that shows in actions, UI, and README badge. We're calling it Playwright CI. Then we have when the run triggers. And in this particular configuration, it will only trigger your CI CD process when you commit something into the main branch, right? Pull requests are disabled, so there are no duplicate executions. But how this needs to be configured, I mean, this is a discussion you'll have with a team when you want to run these jobs. Now, the jobs is runs on Ubuntu latest, so it just provides the instructions what kind of system the GitHub Actions will be deploying there to run it, and it will be Ubuntu. The environment variables we will grab from the GitHub profile that we need to add. We need to add those values there. So for the local, it grabs them from the .env. But from the remote one, we don't upload .env into the GitHub, so we'll have to add them in a special place. But here we have to still define where to grab them. So env variables, test user, test pass, and all, and base URL, all will be coming from the secrets with corresponding names, right? Then steps, check out the repository, installation of the Node.js. So this is like all the configuration step for the GitHub to run. Then installation of all the dependencies of the Playwright, and then it's actually gonna run Playwright tests with npx playwright command, and it always gonna store HTML report because there's if always, and it will upload the artifacts. Okay, so this is YAML file that configuring your CI/CD kickoff on anytime you push something into the main branch. That will trigger our test run. Okay, so this is done. Now we need to add the secrets. So add repo secrets. In your repository, Playwright POM TS, we want to go into the settings. From there, we want to go into the secrets, into the actions. So secrets. Let's click actions, general. Where do we have secret? Okay, secrets and variables, and then actions here. And now we need to add manage environment secrets. So new environment, there are no environments for this repository, so let's create new environment. And what we want to do, the values that we're using in .env, we want to store them here. So test user, hold on, no. Secrets and variables actions. No, not environment secrets. No, not that. We want to delete this environment, yes. Okay, so what we want to do, we want to go into the secrets and variables, click on actions, and then we need to add repository secrets. So new repository secret, we provide the secret name, so test user, and the value that will go there, we just grab it from the .env. The test user is the Tom Smith. So essentially everything that we have in our local, we will have to add in the GitHub, because the actions will grab those variables from here. This way, you don't have any passwords or any users exposed in the code. So let's add new repository secret, test pass, super secret password. Let's add it, and one more repository secret. So base URL, and let's add the link. Okay. So the secrets are all set. Then we can add everything, commit it, and then push it. The only thing that I think was different, and we didn't talk about it, is we added a failing test, and we updated our verification for the checkboxes so it doesn't fail. Yeah, so we added max pixel ratio. So let's update it here as well. This, to have screenshot, will fail because this screenshot was created in the Windows environment, and then GitHub Actions will run it in Ubuntu, right? So in order to go around this, we need to grab this whole block where we now actually don't care about 0.2% of a pixel difference. So 2% of the pixel difference, we don't care about it. Around 380 pixels on a 1080 resolution. So let's update this little chunk of code. Okay. And we also gonna have a fail test case. So in the tests, we're gonna create new file, call it login.fail.spec.ts. And inside that file, let's create a test case. So we're gonna import a fixture, and we'll have a deliberate failure message. So here it says fake user, fake pass, and then the test, if it actually succeeded, it will not succeed. It's asking if I want to install GitHub Actions extension, not now. So it will fail, and we will see this being reported. Okay, so first thing we need to do, let's clear the console, clear. Want to add all of the changes. So we're gonna do git add space dot. And after all the changes been added, we need to commit it with a message git commit -m and updated repo to have actions. Okay, so all of that now is being updated, and now let's do git push. It says, okay, you need to set an upstream repo, upstream branch for this. Let's do it. We're setting it up. Now, when you go to your alexusadays info inside the Playwright POM TS, you will see there are 5 branches. So we actually worked on your GitHub Actions branch right here. And then this will actually kick off the actions that we have in this repository. So you need to do pull request. And let's do pull request. So we're doing pull from your GitHub Actions into the main. And we're changing a lot of files here. Okay, let's do that. Create pull request. There was a typo, so updated repo to have actions. Create pull request. All right, that's a bunch of conflicts. So a lot of stuff that we had in the main was already created. So now we need to override the main branch. Normally, when you do with merge conflicts, you will go and resolve them one by one, select what change to keep, and so on. But we're not doing this. I'm gonna show you something that you're not supposed to do ever, unless you actually know what you're doing and you're gonna ask about it. But since I know what we just created is kind of exactly a copy of what we already have in the main, we want to actually just force it. So what I will use, I'll use a command. So see, git branch. So we're still on the GitHub Actions, and we're gonna do a git push origin your GitHub Actions main force. So now let's go back to the main. So git checkout main, and let's reset it. So git reset hard origin your GitHub Actions, and let's just push this main and force it. All right, so now our main is updated and it's identical with whatever we're trying to merge with your GitHub Actions here. So now we close it, and so here let's do git branch again, git checkout your underscore GitHub underscore actions. And let's do a little README update so there's actual difference. So let's say updated README from your GitHub actions. So kind of know what happened here. I can do git add, git commit -m updated README, and do git push. We have 5 branches. Here's your GitHub actions. Let's do pull request, create a pull request, and what we're doing, well, we are sending our GitHub actions, and we're sending it in alexusadays info main. Okay, so we're sending it to alexusadays info main branch, and we're doing our update from the GitHub actions branch. And we can see there's only one comment that we added. Let's create a pull request. Yep. Create pull request. And it's going out. No conflicts. Merge the pull request. Confirm merge. And it started. And now we can go into the actions and we see that after the merge kicked off, now we have tests running. GitHub Actions is actually running the test that we have in our repository. And what it's doing, so it is using the Playwright YAML config file, and it just goes through all of those commands. It will install Node.js, it will use Ubuntu, it will grab all of those secrets from the secrets where we store them in the GitHub, and then it will run the npx playwright install. It will install the playwright, and then it will run npx playwright test, and it will run all our tests. And it will fail because we have a test that deliberately is failing, this guy. And once it fails, you'll see a red check mark appearing in the README file here. So let it finish. Once it's done. Okay, and it tells us that there's actually some failures. And it created a Playwright report. And you can download the artifact using this link. So let's go ahead and click on the link. Here's our report. Okay, let's extract the files. Report 3 right here. And we have inside an index file. All right, so I think there's still snapshot doesn't exist. So it was a very first run on this test. There was no snapshot. So we'll have a rerun. Okay, we probably need to run it locally then. Yeah, okay, so here's the problem. The snapshot doesn't exist because it was looking for a Linux snapshot. Remember, I told you that the problem that it will do the Linux run and we have only Windows saved. So we can just copy, paste this one here. Let's update it from Windows 32 to Linux. Okay, and another thing, the badge is also not there, so let's update the badge. So it actually does show. And then in the README file, we need to update the badge. So Playwright test, GitHub, alexusadays info. That will be your username So Playwright POM TS, actions, workflow, Playwright YAML badge.svg. Okay, good. So we updated README, we added a file, and now also there was a failing test. We can see in the report another failed test was deliberate failure message was wrong. So now let's make this also pass. So everything next run, everything should be good, and all of the tests will be passed. So deliberate fail, let's update this to the login page. Assert failed username. Your username is invalid. So we're gonna use this method. Login page, and we're doing assert failed username. And I'll update it to this. In this case, this will pass now. This will pass now. Okay. Again, we're gonna do git add, git commit with message final updates, and here we're gonna do git push. All right. With this push, let's do pull request, new pull request, and we want to again do alexusadays info Playwright POM TS and your GitHub actions. So we see all of the updates here. The screenshot added, the test will be passing, create a pull request. So into your username main branch from the GitHub actions that we just updated, create a pull request. And do the merge. And it's running. Now we can look at the tests. This time it should pass, and we're actually going to have an updated badge. You see now it is updated, and it's grabbing it, and it's failing because it's using the previous fail that we had in place. Once it completes the run, it should also update the badge, generate a report, and we will see now all of the test cases are passing. And that's it, and we're done. It looks like the Playwright tests completed running. 5 are passing. And everything looks good. Job is completed. We can go into the upload Playwright report, find the artifact download URL, download it. Here's the index file, and now all of the tests are looking good. This will pass as passing. And if we're back into our repository, we'll go to the README, and why does it say failing? Huh? All right, it's passing, so it needs an update. Okay, here it is passing. All right, this is it. This was alexusadays. Let me know if this was helpful, and I will see you in the next video. Hey everyone, this is alexusadays, and we're continuing Playwright automation with TypeScript. So today we are in module 13, AI-assisted testing, and this is the last module. The future of QA is AI-assisted testing and automation. Traditional automation is powerful, but AI is changing the game. Quality assurance is evolving into more collaborative, AI-assisted discipline where tools can suggest, generate, and verify test logic. I believe that the role of QA engineer will become more strategic, creative, and AI augmented. In this video, we will explore how a Copilot powered by ChatGPT can assist with Playwright test creation and how tools like MCP Server enable a real-time interaction between AI and browsers. What is MCP Server? It stands for Model Context Protocol. And MCP Server model operates within a client-server architecture designed to enable AI applications, particularly large language models, to securely and efficiently interact with external tools, data sources, and services. I think we're entering an exciting era where QA becomes more creative and strategic. QA engineers who learn to work with AI will shape the future of testing. Okay, so here we are at modelcontextprotocol.io in the docs and getting started. So Model Context Protocol is open protocol that standardizes how applications provide context to large language models. Think of MCP like a USB-C port for AI applications. Just as USB-C provides a standardized way to connect to your devices to various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources and tools. MCP enables you build agents and complex workflows on top of LLMs and connect your model with the world. So MCP is the bridge between the AI agent and the real world, be it a database, a web browser, a tool like Playwright. So it can do a lot of different things. And in order to get started, you will also need to have a Copilot in VS Code. So just do a little search. Type in Visual Studio Code Copilot in Google and you'll get to the page where you can download it if it's not already part of your Visual Studio Code. Then we're gonna go into the Visual Studio Code, and here there is a tab called Extensions. Now for that you want to have a latest Visual Studio Code installed. So you have to see the MCP servers. It's quite a recent addition. So this little drop down, then you can hit Install MCP Servers, and then you can choose a different set of tools what you can install, and one of them is Playwright. So we're going to install Playwright. Open up. We have an install button here. Let's hit it. And now we can see that MCP Server is being added. And then we will just start it. So our MCP Playwright is started. Open in terminal, and another tab here on top is Copilot. So I'm gonna hit Copilot, and you can choose one of the standard models. So if you had a paid subscription, you can choose some others, but we're gonna choose ChatGPT 4.1, and here you can see their tools. Configure tools. You want to hit Configure tools, click on it, and see that you actually do have MCP Server Playwright, and it's checked. So all of the different commands that we were issuing to open a page, to click on element, all of that stuff is built in within the MCP Server Playwright. Now the AI agent, the Copilot with ChatGPT, can actually go to a web page and build test cases. So I will ask, so for our application that we were testing, let's go and grab a login spec, open it up. And here, so we have a login flow that we created. Let's see if we can create now using the AI, right? Within the context of the framework that we created, if the AI can actually add a test case. So let's go ahead and grab test data, and let's actually in the env file, let's grab the URL. And I'm going to ask ChatGPT and the Copilot, can you use MCP Server Playwright to analyze this page. And yeah, I'm providing the page. Okay, now you can see that MCP server is running because it's saying I will run navigate to this particular URL, and it's asking for your permission. So obviously when you use AI tools, and especially if you're going to do it at work, you have to know the policies around it, and you have to ask if that's okay to use them. And then you have to know where you go and if that's a safe web page. That's why it's asking for permission, right? So you confirm that, and it's going to the page. It's going to analyze the page. And now it is a combination of things. So it is a copilot, it is using LLM, and then LLM using MCP to navigate to the page, and it looked at the page. Can you create, let's ask, can you create a text file with a list of possible tests for this page? Just a few as an example, and let's see if it gonna do that. And I am running it as an agent mode. So when you have an agent mode, you can have ask mode or you can have agent mode. If you have agent mode, it will be able to edit and create files. And now it just created a list of test cases here in the login page, test-ideas.txt. And it says login with valid credentials, login with invalid username, login with invalid password. Fields should be visible and enable. Login button should be visible and clickable. Error messages should disappear after successful login. Password field should mask input characters. Page should display instructions for login. Okay, let's keep the file. Good. Let's ask it. So in this Playwright implementation with POM and fixture, can you create a spec file, separate spec file? And so let's see if it can have a test that will verify that password fields mask input characters. So number 7, and test number 7 scenario that you created. So I want to see if it will be able to produce a spec file. Here is a spec file being created. So login password.mask spec.cs. All right, so looks like new spec file was created, password field. However, there are 2 issues. So not exported, POM fixture, and login page does not have password input method. All right, so first, let's take a look at our fixtures. Okay, so please see POM fixture TS and other spec files as example on correct implementation and update your test, plus you can create a method that you need to do the assertion. All right, so let's see if that's going to help. Now it's analyzing the project, going through all of the files. So in the login page, it's adding password input. Okay, let's do that. Gonna keep it in the spec file that it created, so it's updating. It's actually doing a correct thing now. Instead of importing POM fixtures, it imports the test. So it's going with the login page and then password input, grabs the password input, have attribute type password. All right. One thing I want to confirm, will this verify test case that you created? How do we know? How do we know that password is masked? Okay, let's see. Yes, the test verifies that the password field is masked by checking that HTML type attribute is set to password. Okay, so type password automatically hides masks and the characters entered display in dots. All right, perfect. So now let's try and run it. I can run it through the chat. Can you run only your test? And it's asking to run test, again, asking for permission. Let's say continue. We should see execution now. One worker, one test, and it appeared right here, and the test is passed, and it reports the test login ran successful and passed. This confirms that the password field is properly masked. Okay, that is great. Now let's try also doing it manually. npx playwright test --UI, and I'm gonna run this test here so we can visually actually see what's going on. So here's our login password mask spec. We hit run. Okay, let's go. So it went, navigated to the page, found the attribute, and it verified that it has attribute password. The test case is passing. It did need some help in the prompt, but you've seen that it actually was able to analyze the project, correctly import the test from the fixture after we asked him to go through the project and analyze it. It updated the test case. I used the method that already exists in the login page to open it up, created new method to do the password input, and did an assertion. That is pretty cool. So all of that was done by the AI, and if I didn't know any coding, or I know you just a little bit, I could help and manage from the point of creating a test file with a set of test cases that AI can help out building, to the point of actually creating the automation for those test cases within the framework that we have, which is pretty awesome. So I think that's a good way to expand coverage and to add additional scenarios and have AI help you creating the tests and automation for them. Okay, and that's it. This concludes our course. This was alexusadays. It was a pleasure teaching you and showing you all this, and I wish you all the best to get going with your project, with your testing effort, with being a QA automation engineer, using the AI, using Playwright. And I'll see you on my next courses. Thank you.